Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. So today we're going to be continuing with the convolutional chapter that we were working on yesterday. Radu and anyone who might be lurking in chat, hey, thanks for being here. So yeah, I think we're just going to go ahead and hop right into it. I don't think there's too much to really talk about since I did the stream yesterday. I will say that this morning... You know how I say I'm miserably addicted to certain games? Yeah, one of those games was Guild Wars, and I did start thinking a lot about like Guild Wars challenge runs we could do, but I was like, man, no one's going to be into that. There's no way anyone would even care about that. Emrys, thank you so much for the 9-month subscription. Let's go ahead and put Simule Cows in the chat. Simule Cow, I think 9 of them, so that's 1. And then we have a lot more left to go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Thank you so much for all the support. Really appreciate it. But yeah, I don't know why, but this morning I just started thinking about those Guild Wars challenge runs. And I'm like, come on. Like, why am I even thinking about this? But I thought of things like, you know, a Guild Wars Nuzlocke challenge where, you know, you could only, you know, pick one skill from every area, essentially. You know, a spell list challenge, all this kind of stuff, and I was trying to suss them out, see how we do them. But honestly, again, probably almost certainly not going to happen because I just don't see people on the stream particularly interested in it, and also I'm not particularly interested in it. You know, like, the more I think about it, the more I realize, you know, I'm going to just become mindlessly addicted to the thing, and I'm going to hate myself for doing it. So I figure, let's not do that. Are you a fractal yet? Not yet, no. We're working on a bit of the Becoming a Fractal saga where we're focusing on convolutions and trying to get the convolutional chapter in the algorithm archive. So the actual order here is 1 week to finish up convolutions, another week to finish up affine transformations, and then I think the 3rd week is to finish up the fractal flame method, and then after all of that is put together, oh, and then we have the 4th week for genetic algorithms. So it's looking like a month out until this is basically done. But once it's all done, we'll have all the chapters in the algorithm archive, and hopefully the code will be up and ready to go. So it'll basically be a month until this saga is done. I'm going to hop between different topics as well. I won't only be doing Becoming a Fractal. Sometimes I might take a step back and we might do the Quiltify project and other things that I feel like we need to do. It just kind of depends on what I'm feeling like doing that day. Again, I'm kind of taking a more casual approach to streaming in 2021. So my goal is just to kind of make sure that I'm doing a stream every day, even if it's not like the, you know, most impactful stream, like it's not getting the most work done. At least we're chatting, hanging out, and just kind of working towards a goal. Because that's something that I was not doing a very good job of in 2020, or 2019 for that matter. I mean, actually I published a whole bunch of papers in 2019 and my thesis and stuff, but as far as online content was concerned, I didn't move anywhere near as far as I wanted to. Okay, so I'm gonna open up a new terminal. I'm gonna cd into project Simuleos, and then I think convolutions, L is here, and then mpv out 6, I believe it's called, that mp4 loop, 1 second, loop 0. Okay, there we go. So this is where'd it go? Chotomate. There we go. So this is the visualization we made yesterday, basically just getting the workflow under wraps. So what is this that we're looking at? So this is a convolution of a Gaussian with another Gaussian. What you'll see is that as the Gaussian is moving across the other one, all of the points that overlap, that is to say, all of the elements here and here, for all of those points where the two Gaussians overlap, we multiply the two Gaussians together, and we get this new Gaussian that's kind of this little green guy in here. And then the area under that green guy is equal to, or turns into, the convolution in that place, right? So usually convolutions are used for image filtering and stuff like that, to blur areas or maybe find corners or edges and that kind of stuff. This is the heart of that process. It's still doing the same thing. It's just that it's over a larger signal. So today we're going to talk about what happens when the filter is small. So we want to do the same visualization just with the small filter, see if it works, try to make sure that that workflow also works out, all that kind of stuff. Guepe_ yo, how are you? I hope you're having a great day. So let's just go ahead and hop into the code and see what we can do. Oh, hello, 1 second. Yeah, also guys, like, I'm sorry, I'm so lame. CD Projects Simuleos Convolution. So CD Projects Simuleos Convolutions. What is 1D? 1 dimension? Like a line or something, as opposed to an image, which is 2 dimensions, or a cube, which is 3 dimensions, or a tesseract, which is 4 dimensions, or a whatever the 5-dimensional cube is. Like R? Wait, I missed something. Not R times R. Oh, right. All real numbers, not real numbers times real numbers. But yeah, I'm actually interested to hear the other streamers that you guys watch, like what you guys are interested in watching on Twitch. I'm just trying to get a quick survey to see how many people do we have. We only have like 10 people watching right now. That's okay. But you know, like if you guys have other streamers that you like to watch on Twitch, I'm interested to hear what type of content you guys are into. Is it mainly gaming content? Is it mainly science and tech content? That kind of stuff. Hey, C252, how are you? I hope you're having a wonderful day. Okay. So again, what we're going to work on now is basically just fixing up the convolution visualization so that we can use it with a filter as well, not just two large signals. And that's what we're going to work on. I watch chess streams sometimes. I'm watching a GeoGuessr streamer. Oh, interesting. Besides, not that much. Pretty much only programming. That's fair as well. Yeah, see, that's what I thought. I figured most people that were watching this stream probably watch, you know, a game engine development, like mostly programming and like science and tech content. I imagine probably moving into game development. What I was interested to hear is if you guys watch any art streams. I really am into art streams. I don't know why, but just the casual nature of art streams where people just kind of chat and do a bit of work and chat and do a bit of work. I quite like that. Not so big into chess, but that might be because I'm not so big into gaming in general, and chess falls into that category where it's kind of, I don't know how to put it. You know, when you're doing science, I follow Bob Ross. See Lou's streams where she makes music. Oh, yeah, that's cool. What I was going to say is that, you know, when it comes to science, like everyone has their own kind of terminology, right? Like, you know, some sort of jargon that makes sense within the confines of their scientific domain. And the same is true for you know, gaming streamers, right? Like if I play Guild Wars, I know exactly what people are saying when they say condition or they say hex or they say X, Y, or Z. I know what all these mean because I know the jargon for that particular game. The problem I have with chess in particular is that I don't really know the jargon for chess. I mean, again, I used to be in chess club when I was like really young, but I just don't know all the strategies or like what's considered a good thing or a bad thing. It's all this kind of stuff that I don't fully understand. But the way I see it is, you know, when it comes to this type of stuff, I feel like people aren't so interested in chess. I feel like it's the same with every other game where like if you have a good personality playing the game of chess, you kind of like the personality more than the game, right? Like even if the streamer is like a fantastic, you know, chess player, it's really you're there to hang out with the person more than you are there to watch the chess stream. It's just that chess was what kind of brought you in, you know? I don't know if that makes any sense, but I feel like it, for the most part, like if you have all these games that are like, you only have like 15 or 20 viewers or something like that on average, I feel like if you just had a really good personality that just came in and dedicated themselves to the art, or that game, like it would suddenly become popular. I don't know how true that is, but I've been thinking about that recently. Julia over here, G down here, we have main, so now I'm going to create Y. Okay, I'm going to try to create this convolutional plot, the same thing that we just did. So the same exact, like, thing that makes this video up there on the upper left, but this time I'm going to modify this so it's just a very simple filter that we're going to say is just a triangle filter. So we're going to do DT here, and we're going to do 1, 2, 1. And let's just see what happens. And also we're going to normalize Y. Sure. Y. And I think we need to do Comentamo. Okay, let's try that. So if we include convolution.jl, let's just see what this does. Honestly, I find the personalities of a lot of the big chess streamers kind of irritating, but I still watch them because they're good at explaining stuff. That's fair as well. I mean, it could just be the explanations that people quite like. So if I run main here, it should do something. Right. Okay. No idea what that is. So let's go to line 86. It doesn't like normalize X. Oh, Y. And let's make sure these are integers now. Here, there, and there. Add some spacing for consistency just to make it look a little prettier. Try that one more time. There we go. See what happens this time. Bam, look at that. But I can see how the visual applies to audio, but the image is harder for me to think of. Why, Julia, mind you, I know pretty much nothing about it. Honestly, is mostly C, C++. Is this Fourier transform stuff? No, so we took a step back from the Fourier transform stuff, and we are focusing now on just convolutions without the Fourier transform. So this is convolutions without the convolutional theorem. Guepe, could you ask your question again? Because I'm not entirely sure I understand what you meant by that. I can see how the visual applies but to audio, but images is harder for me to think of. Yeah, sorry, I'm not fully I don't fully understand what you're getting at there. Oren, why Julia? I'm using Julia just because it's relatively the same speed as C in terms of performance. Admittedly, you still have to deal a bit with precompile time, which takes a while, but ultimately is relatively as fast as C in terms of runtime. And it's also a lot easier just to do basic stuff, so that's kind of why. How does the plot relate to 2D image processing? So right now it's just a 1D version of 2D. Let me see what these images look like because it might be closer. Let me just do Mirage. I believe that should do. Okay, so we should see, yeah, see this is two Gaussians. I didn't want two Gaussians. I'm gonna try this one again. We're gonna do X and Y. Y should be the signal. Okay, so the usual way this works is that you have, so if you see this kind of red Gaussian that's moving across, usually that is some sort of filter that is being applied to some sort of image. So in this case, the image would be the blue in the background. So you could imagine, you know, for example, if it's a black and white image, it's incredibly white here and incredibly black here. And so what you're doing is you're taking this image and you're applying a filter to it, which basically will smear out all of the pixels so that, you know, they're connected to the pixels next to them or something like that. So the idea is as this Gaussian moves across, oh, well, let me try that again. Let's wait. So as this Gaussian moves across, now this pixel that represents maybe the center of this Gaussian or something like that is now a combination of these two signals put together. So the idea is you're relating these two signals together. You're combining them together in such a way that you're like adding pixels together or something like that. And so that's kind of how it's related to image processing. So is the x-axis color and the y-axis the number of pixels that have that color? In this case, we're not really dealing with image. Just for the record, this is not an image convolution. This is a 1D convolution. You could imagine it's like a 1D image. So is the x-axis color and the y-axis the number of pixels that have that color? No. So that in this case, the x-axis would just be the pixel, like each individual pixel would be the x-axis. So this is just pixel 0, 1, 2, 3, 4, 5, 6, blah, 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 is pixel 100. And then on this axis would be how black and white it is. It's literally just like an image that's spread across one line, if you were to think of it that way. The only reason I was describing it as an image was because Guepe mentioned that he wants to see how this is related to 2D image processing. Right now, we're not at the image processing step. We're literally just taking a look at this as if it's two separate signals, which is still very useful for other domains. It's just usually when you think of convolutions, you think of it in terms of image processing. All right, let me try running this one more time. Include, and then we run main again. Error, right, good, wonderful. No method matching convolution plot for array float 64, array float normalization factor. Could also be single stripe of pixels or audio samples. Right, it could be a number of different things. So single stripe of pixels was what I was describing as it's related to 2D image processing. But yeah, audio samples or something like that is also what this could be. It could be a number of different things, right? Convolutions are useful for like a huge number of things from, you know, from image processing, but also PDE solving of partial differential equations, this type of stuff. It's useful all over the place, you know? Okay, so what am I doing with my life? 1 second, why is this breaking? It says it's breaking on line 53. So if we go to line 53, what's the issue here? It says convolution plot. It's just saying that this doesn't exist for... Okay, I see. And that's because I specifically said these arrays should be complex. So I'm just going to add a plus 0 IM to this. And let's just see what that does. Include main error attempt to access 3 element array at index 1 to 99. Okay, I think the reason is... Let me just go to line 88 here. Yeah, that's what I expected. So now we're going to go to line 76. Yeah, so I think the reason is that I specifically had this move across... Okay, so we have I as the time domain, and then we have J as the... Then we have J as the inner domain between the signals. Okay. I think that comment is wrong, actually, now that I look at it. Okay, let's just kind of go through this convolution and see how it works, because at this point, I'm kind of a bit... Now, we did a convolution for other things. What was the convolution for? I feel it was for something related to class, but I don't remember. Oh, no, we just did it in the Fractal Flame library. Right. So worst case scenario, we can take a look at what we did in the Fractal Flame library and see if if we need to look at that in order to understand convolutions again, because honestly, it's been a while since I implemented this, so I'm kind of a bit, I've kind of forgotten exactly how this works. So, like, I know in principle, but in practice, I'm a bit behind. So, 1 second. Yeah, sure, whatever. Okay. Yeah, so I guess the other thing I was going to mention, just to close up that topic of other Twitch channels that you watch and stuff like that, if there is something that you kind of want to see me do on stream, just go ahead and let me know. Again, I'm planning to do longer streams. We tried some like programming challenges and stuff like that, which I thought turned out pretty well, but people tended not to be super interested in them on Twitch. And so I was thinking about maybe turning them into YouTube videos, but honestly, like, I just didn't like the idea of doing these Twitch challenges on YouTube. You know, like we did an Arch install speed run. We did a Twitch challenge where I couldn't see what I was typing. So like the Twitch chat and everyone like on stream could see what I was typing, but I personally could not. So I was basically just using Vim, and just based on what I knew from Vim bindings, that worked pretty well. I have no idea what I'm looking at, but just want to say hi. Hey, Micah, how are you? For those of you guys who don't know, definitely check out Micah's YouTube channel, which is Neurotransmissions. It's pretty good. I think you guys hit 100,000 subscribers just recently, didn't you? I feel like recently might be sometime this year. My perception of time is like incredibly off. I feel that's true for most people in 2020. I was hoping that now that we're in 2021 that like I'd start to be able to function like a normal human being again, but we'll see. Okay, so what do we have here? We are trying to piece together why this convolution is dumb. Right. Okay. Attempt to access 3-element array at index 1 to 99. And this is going to be specifically on line 76. Here. Signal plot. Oh, it's only in the plot, so the convolution works just fine. Perfect. Okay, then I'm not as dumb as I thought. 12. It is here. Print line I. How is it on that line? There's nothing wrong with line 12. Let me try this again. So I'm going to include this again. And now we're going to run main. And just to make sure it's on the right line. It's line 14. I don't know what was... Wait a minute. 14. Well, okay, let's just try to figure this out. Physics O, thank you so much for the raid. How was your stream, man? I hope you're doing okay. Pony raid. Fair enough. Cosmolino and also Entropic Universe, thank you guys so much for following. Really appreciate it. Hey, Physics O, how was the stream, man? I hope you're doing okay. Non-dairy neutrino, hey, how are you? Physixo, Jax, what's up? Right, so today we are working on a big project that is specifically for, it's entitled Becoming a Fractal. The idea is that we combine a bunch of different things together. So we already have this image creation thing. Let me just go ahead and go there. Projects, Flamify, here, LS, and let me just do Mirage, I guess, what do I have, check.png? Okay. So we have the ability to generate images like this, which is a combination of different fractals put together. So it's called the fractal flame method. And let's see, so we can create like weird heart-shaped things. I don't know, like these are just two separate sets of like fractals that we've kind of put together. But there's essentially like an n-dimensional plane to traverse where we have like n fractals. And we have n affine transformations that we can do to said fractals with, I believe, 6 possible operations in each affine transformation. So this means that we're like a 6 times n, 6n squared dimensional space, I suppose is what you could say, where n is the number of flames that we could look at. And the idea here is that what I want to do is I want to be able to put an image into our function or whatever, into our code, and then output a set of fractal flames that look remarkably similar to that image. So basically turning any image into a fractal. That's kind of the idea. We're going to see how far we can get. Today we're working on we're very far from that goal. But we did get the fractal flame method working. So now we're taking a step back and updating the algorithm archive with specifically convolutions. So the reason we need convolutions is because if you look at this check image in here and you look up here, we actually do a blurring effect on basically low pixel density areas, and that blurring effect is done via a convolution. And so today we're just looking at what convolutions are and that type of thing. For those of you guys who don't know what the algorithm archive is, let me just go here and go to algorithmarchive.org. It's essentially a place where we're putting essentially every algorithm in existence in as many languages as possible, right? So the idea is you go to, I don't know, Gaussian elimination, you scroll down to the code, and you can switch between whatever languages we have available and stuff like that. And so the idea is we're doing a learning resources, we're doing a learning resource for people who are interested in learning about this type of stuff, but we're also trying to build big projects and stuff like that. And eventually these projects end up on the YouTube channel, along with the algorithm archive. Oops, sorry about that. Algorithm archive. And then obviously here on Twitch. So that's kind of the whole thing. I'm going to catch up on chat in just a second. Gep, Eoi, and also Lozid, thank you guys so much for following. Really appreciate it. Let's see what we have. Lots of physics O's. It was good. Yeah, I'm happy to hear that. What did you guys do in stream? What was going on in physics O stream? 2020 was the first after 3 leap years that did not have a leap second. Huh. What language are we coding in Julia? Let's see. Convolutions. Let's see, find out more. I guess I should do the coconut Gaussian elimination. The problem, okay, so the big problem we have with the algorithm archive right now is we don't have enough people to review the languages that people submit the code in. So we have a lot of open PRs because I don't have the expertise to review the PRs. So if you go to the algorithm archive right now, just go to GitHub. Here, I'll just show it to you. Why not? github.com, and we do the algorithm archive, and we do pull requests. If you just see a language that you know, Racket, Python, actually, pretty sure anyone can understand Python. In fact, I could probably do that. Maybe I'll do that review later. I don't know why that review's not done. But PowerShell, lots of these guys in PowerShell, Rust, any of these languages, just feel free to come in and just make sure if you can read the code and the code looks reasonable. That's all I need. I just need to know if the code looks reasonable. I can check the algorithm. I just need to make sure the code is like a reasonable form of Coconut code, a reasonable form of PowerShell code. I don't know. That's the thing. I just need to kind of, hear that the code is legitimate code. And then after that, I can usually merge it. So let's see, what do we have here? Add them all together and negative plasma. Thank you guys so much for following. Really appreciate it. We tried to do some signal analysis on a piezoelectric from a lighter. Oh, how did you do that? With, I'm assuming some form of a Fourier transform to get... Yeah, we did that a long time ago at OIST, so it was just via a hacka-thingy, not a full hackathon. And the idea was that we put a piezoelectric on like some sort of wall, and we started typing on the wall to try to locate where you typed, so that you could essentially just put the electric on a wall, and then you could just like type as if you were on a keyboard, and it would understand that type of thing. Implementing flood fill in PowerShell sounds like doing it in BF. Yeah, a little bit of that. The Python stack in Qcode is not merged because you did not update the chapter to add some code yet. Oh, okay. Thank you for that. I should probably do that. That's fair. That's my fault then. Let's get this convolution example working, and then we can go from there. So n is the length of signal 1, and I suppose what I need now is we need n1 and n2. So yank paste, n2 is going to be the length of signal 2. Because in this case, we had assumed that signal 1 and signal 2 were the same. And so it's going to be n2 minus 1. Sure. And let's just look for any of the n's. Yep. Signal 1, signal zeros of n. What is this for? This is for area under FG. I believe this is going to be n1. And I believe that's all the n's we have in that function. So let's go here, try to include it again, and see if we can just run the animation again for a smaller filter. We could not. Ogre Org, thank you so much for following, really appreciate it. Let's see, what do we have here? Arrays can be broadcasted to common size, got dimension with length 103. Right, okay. So what's this error on? It's gonna be on line 16. It says convolution sum is gonna be real signal 1 dot times shift signal. Right, and that is because the convolution sum, Dark Link 701, thank you guys so much for following, really appreciate it. Okay, so we have the shift signal is going to be the real here. So the shift signal is phenomenally smaller than the convolution signal. So do I need a 0 pad? Maybe. Let's see, I'm new, what program are you using? I'm writing this code in Julia. Let's see, what do we have here? Implementing flood fill in PowerShell. Are certain functions in Julia whitespace sensitive? I just noticed your part and list specifications are rather compact. No, they're not whitespace sensitive at all that I'm aware of. No, in fact, I don't think anything is whitespace sensitive in Julia. But I do like to make sure that I have a consistent style in my code. And I also, I mean, yeah, I know there's all this discussion of whether you should stay to the 80 column rule. I get that. A lot of people don't like sticking to the 80 column rule, but specifically the way that I code, I prefer to stay to a smaller number of columns. So I will sometimes break up code if it's beyond 80 columns for a number of reasons. One is that I code predominantly in the terminal, and the terminal, when you open it up, is always 24 by 80. But also, I feel like it is easier to read code when it is vertically long than when it's horizontally long. Just for me personally, it is easier to read a long vertical code than a long horizontal code, if that makes sense. Academic code with consistent styling. I mean, look, at some point, someone had to do it. Someone has to have consistent styling in academia. And if I'm the one to break the trend, by golly, I'll be the one to break the trend. I don't know if that made any sense, what I just said there, but I'm going to pretend it did and keep moving on. Okay, so what's the issue here? The convolutional sum is going to be the real dot times the shift signal. Now, where do I use the convolutional sum later? Let's just look for underscore sum. We have it there, and we have it here. So it's used, for the ribbon plot, of course. Okay. So the question then is, let's see. It's going to be one dot times the other. That's totally fine. My question is, how am I going to do this with a small filter? That is my question. And I don't really have a good answer to that because we're essentially doing another convolution on top of this. Don't stretch me. Yeah, I was thinking about redoing the simulterm emote, but very few people use the simulterm emote. Most people just use simulcow. And let's see, I mean, some people use simulwow, but what other emotes do we even have here? So we've got, I think I only have 5 emotes right now. 4. I should have more than 4. Wait, why do I only have 4 emotes? Wait, where's my simulwow emote? Wait a minute. Oh, it's up. Okay, weird. For some reason, I can't see all the emotes on my screen over here. But there are 5 emotes. There should be simulterm, simulwow, simuljulia, simulvi, and simulcow. And most people use simulcow. So, thanks, Lord Lycon. Appreciate it. I think I have the ability to make more emotes. But I think I just kind of left it at that number and said, whatever. If I want to make more emotes, I can make more emotes later. It's just, I couldn't think of any. I had to, really think about what emotes people would actually care about. Simulwow is just one that, like, I don't know, people were asking for. So I was like, okay, we can do that one. But simulcow makes a lot of sense and I think looks pretty good. Simulvi looks pretty good. The other one, simuljulia and simulterm, maybe not so good, but whatever. They're okay. Okay. So what I need to do now is I need to make it so this convolutional sum. Okay, I see exactly the problem here. So in this case, the 2 signals are of different sizes, right? And that's the big problem. Signal 2 is way, way smaller than signal 1. And for that reason, we have 2 different lengths for signal 1 and signal 2. So I think I need to have another kind of method that we dispatch on if signal 2 is smaller than signal 1, which is the case for when you're doing filtering, for example. So here we have these guys, and we're just going to say if signal 1. Yeah, no, okay, I got this. I know exactly what I'm going to do. If signal 1 is equal to signal 2, what am I doing? N1 equals N2. Equals, oh, come on, I can type. N2. Then we're going to say that is equal to that, should be fine. And there. In fact, maybe I just need to do this, paste it up here, and then I say if N2 is less than N1. Yeah, whatever. And then I'm going to modify the shift signal in here. So yank, paste in here. And what I need to do is I need to 0 pad it. So the shift signal will be the size of signal 1, but it is kind of shifted so that, like, it's only 3 elements, but signal 1 could be n elements, where n could be like, I don't know, 1,000 or 10,000, whatever. So if you have 3 elements, you got to move these 3 elements across like this. So you have to figure out which elements you need to move across. And that's what we need to do. So what were we doing before? Before we said shift signal will be the real of signal 2, which is the signal that we're reading in, from I to 2n minus 1, and then signal 2 from 1 to I. So essentially what we're doing here is we are concatenating signal 2 and we're splitting it up. So if I is equal to 1, it goes well, okay, let's say I is equal to 10. It goes from 10 to the length, to the end of signal 2. Oh, I see. We're literally just kind of like moving it across. Yeah, that's totally fine. Did you ever look at the 1729 dimensional convolution galactic algorithm to multiply two numbers together? No, not yet. We were still focusing on the Schoenhagen-Strassen method. I never even got the number theoretic transform fully implemented. Honestly, I mean, I've said this before on stream. I've just been really burnt out since the end of the MIT position, and I've been having a lot of trouble just kind of getting into new technical things. I don't know what the deal was. Like when I left OIST, I was super into like anything. Like if I just found a paper, I would read it and I would love reading it. But I don't know, ever since I left MIT, or ever since like halfway through the MIT job, I've just started really disliking just reading up on new algorithms and stuff like that. It's been not disliking it. I get the same feeling that I get when I'm playing video games, where I feel like I'm wasting my time, even though I'm not. That's kind of like that. That's how I feel. Good afternoon, or is it evening? I think it's still afternoon. It's 4:30, so I definitely would consider that to be in the afternoon. But yeah, I guess the point is that like, I actually genuinely enjoy reading technical content. It's something that I very much like to do. But with the MIT job, I was conditioned to feel a bit, I don't know how to put this. When I read stuff on algorithms, it felt like I was doing stuff that I shouldn't be doing. Even though it was stuff that was totally related to my job, it just felt like I shouldn't be doing it because it was something I enjoyed. And the problem was because I didn't really enjoy doing the work for MIT so much, I felt like my entire life should just be filled with stuff that I didn't enjoy. I don't know if that makes sense to you guys, but I'm hoping that you guys kind of understand. You know, like there's... if you like play a video game when you should be working, or like you're watching television when you should be working, or really doing anything when you should be working, that's the feeling that I got when I was just doing, like when I was reading papers and stuff like that weren't related to my job, you know? Farrah burnout is very real. Are you still working at MIT? I will not be working at MIT in 2 days. So Tuesday is my last day that I will be working at MIT, and so I'm officially no longer working with them. It's going to be a really weird year. 2021 is going to be really weird. I'm excited for it, and I'm really doing my best to just kind of overcome that burnout and just start working on things. Where are you working right now? I can't really say right now because it's a bit top secret, hush hush type of thing, but hopefully in the next few weeks I can explain it. So for now, for the next 15 days, because I don't have any job for the next, well, until January 15th or maybe 18th or something like that, whenever that job starts. I think it's actually the 18th. I don't actually have any job in particular that I'm working on. It's mainly just, it's mainly my online content that I'm working on full time. And I know a lot of people think it's a bad idea, especially when you have a Twitch channel that barely has 50 viewers. That's totally fine. I totally get that. But I have a lot of reason to believe that if I actually do focus on my channel full time, I can make that work. I see there's no NDA. There's no NDA for the NDA. NSA, you mean? Walmart Reader. It's not that there's an NDA or anything like that. It's just that yeah, Happy New Year, Strix, how are you? No, it's not that there's an NDA on it. It's just that I don't really want to talk about it too much on stream, for a very particular reason. And that is that, oh, I'm not going to say it. Otherwise, you guys are going to know exactly what the job is. So I'm just not going to talk about it yet. Just because there's a very particular reason I don't want to mention it on stream. I will explain when I want to explain that reason. That time is not now. Okay, so what are we doing here? We have the shift signal, which is going to be the real part of signal 2, concatenated with signal 2. That's totally fair. So what I think I want to do is I want to say, if N2 is less than N1, I'm actually going to shift signal 2 by a bunch of zeros. And that's just what we're going to do. So we're going to do D3D, paste it up here. And now we're going to say signal 2, D $, signal 2 is going to be equal to zeros. And it should just be of length of N2, N1 minus N2. And we're just going to pad it with zeros. So this is then going to be concatenated with signal 2. Let's just see what this does. I'm kind of feeling that it might be a bit weird. So now we're going to have another else if here, just in case. Else if N1 is greater than N2. 1 second, N2. And we're going to say signal 1. 1 second. We're just going to grab this guy, paste it down here. We're going to say signal 1 is going to be 0 padded with the other one. So signal 1 is going to be zeros of n2 minus n1, signal 1. That should do it, I think. So let's just see what happens if we include this again and we run main. Arrays could not be broadcast to a common size, got dimension with length 103. Okay, so this is going to be on line 21. And it's here, convolution sum, But shift signal should now be, okay, let's just figure that one out. Dix3, thank you so much for the sub, really appreciate it. Let's go ahead and put a simulcow in chat for that one. I hope you guys, I hope you're doing a great job, or I hope, what am I trying to say? Thank you so much for the support, I really appreciate it. Let's see. He's sub to kick off full-time streaming. Also, for the record, it's not so much full-time streaming as it is full-time like content creation. So that's streaming plus algorithm archive plus YouTube for the next. Again, it's just for the next 15 days or so until I have the other job lined up. I'm doing okay, so I can manage that okay. But I am trying to do, I'm trying to get back into the consistent streaming vibe. And then once I get back into consistent streaming, I'm going to start like increasing the stream time and stuff like that. Just kind of go at it. The truth is, like, streaming is one of those things that I do enjoy. And I feel like every time I hop into it, it's like, oh yeah, I'm really enjoying the time when I'm streaming. It's just sometimes I get a bit burnt out. And that's just because, the specter of MIT still haunts me a bit. But even so, the MIT job wasn't bad. It was just that it was a lot of work and you get kind of grindy, Okay, so I believe that for some reason signal 2 is maybe too big. Let's just output the length of signal 2 here. So we're going to print line. Oh, I see. Wait a minute. Okay. In this case, this should be N1. Yeah, that should be N1. Because now signal 2 and signal 1 are the same length. But just to be sure, let me just go ahead and do print line. And we're just going to do N1 and then new tab. And then we're going to do length of signal 2. Just to make sure they're the same size. Go over here and we're going to do include. Try running it again. And we get 100, 100, undefined variable error, and n not defined. Totally fair. Where's that? It's on line 25. That's line 25? Oh, I see. Zeros of n1 is what we need. Okay, so let's try that one more time. Include main. Okay, we got some images, but then they started not working after some point. So let's just go up here, remove the print line statement. Oh, actually, what is going on here? Bounds error. Attempt to access 3-element array. This is on line 75. I see. 1 second. 75. So the residual sum. Actually, I don't know why I keep calling it rsum. I think it's just because sum is a function in Julia, and I just didn't want to like override that or something. I don't really remember. Anyway, we have rsum is going to be plus equal to signal 1, and then signal 2 index modulo length of signal 2 plus 1. Attempt to access 3-element array at index 0. Okay, well that would be an issue, wouldn't it? Why are we accessing it at 0? So index. What is index? Index is going to be equal to j minus I. Okay. J is going to be the length of signal 2. If the filters and the signal are shifted, is the output just shifted? If the filters and the signal are the same, is the output just shifted? I'm not exactly sure what you mean. Sorry about that. But essentially what we're doing is we are calculating the convolution at every step. So this loop is going through here. Let me just try to explain. So this loop is going through and calculating this kind of pink curve over here, right? And so, for example, we're at this point generating the pink curve. And what I'm doing in the visualization is I'm then going to take these two filters or two signals, and in the visualization, I'm then going to shift the signal over, and I'm going to calculate this guy. So the idea is that I have two separate functions, one of which just calculates the convolution at every point, and then I just read that data in to do the visualization of what we know is actually happening. If that explains it. I don't know if that actually was a good job or not. Let's see. So let's see, the residual sum here, so we have signal 1 of j, signal 2, index is going to be j minus I. If j is less than the length of signal 1, we're then going to say j minus I. So j minus I is going to be 1 to n minus 1, where n is the length of signal 1. So if j minus I, so j is going to be the length of signal 2. The output is Gaussian here too. Right, yeah, so the output here is also Gaussian. The reason for that is because we're just convolving two Gaussians. If I were to change this so it was like a square wave or something, in fact, let's just go ahead and do that right now, so you can see that visualization. I can't because the code's broken. Well, maybe it's not broken. Let's just see what happens if we change it so y is equal to x. So y is equal to x, just to make sure this still works. And I can show you a new visualization in just a second. Let me see what happens if I include this, and now we do conv main. Okay, so this one still works. So what I will do now is I will say y is equal to this. So y is going to be equal to zeros. In fact, let's do this the other way around. So we're going to say y is equal to Gaussian. And then we're going to say x is going to be equal to... I'm just doing a bad job with this. I'm sorry about that. Y, x. And I'm going to comment these guys out. And we're going to do two new filters in here. So x. Paste. And this will be y. Okay, so y will be the Gaussian. X is going to be equal to $$ zeros. 100 zeros. And then we're going to say x. So we're going to create like a square wave in the center. X from, I don't know what this is going to be. Let's just do, how about 40 to 60 is going to be dot equals 1. Something like that should do. Write this, and now we're going to do include, and then we try running main again. No mathematical convolution plot, array, float 64. Right. So this has to be complex. And then this should be 1 plus 0 IM. I'll fix the complex stuff in a bit. Method error, no method matching convolution plot. Array complex 1, array complex float 64 1. Okay, well, let's try that one more time. Float 64. Include main. There we go. And then this should create some new visualizations, which should be shown here. Mirage. Okay, so here we have a square wave. Well, okay, it is what it is. So here we have a square wave, and you can see that the convolution here, this little green bit, the area under FG is kind of a bit different in this case. And you'll see that the overall convolution does actually look quite a lot like a convolution, or like a Gaussian still, doesn't it? I think that's specifically because... yeah, our Gaussian's too big. Okay, let's modify that one more time so it's not quite like that. So here we're going to do divided by 200? No, I think divided by 10. Try that. Now we're going to do include main, and I'll show you this visualization once it's done. Let's see. Now we're going to do Mirage. Okay, so now we have a very, very sharp Gaussian. And okay, so here you see, yeah, that's what I wanted to see. Perfect. Okay, so here you see that the output convolution is kind of more like the square than it is like a Gaussian. It's just, so essentially the convolution is not always a Gaussian, right? The point is that, like, depending on what you read in, you're going to get something out. The reason we were getting Gaussians is because we put two Gaussians in. There's a lot of, like, little things here that I'm really kind of glossing over, that I'm still trying to make sure I have a good understanding of, which is why I'm happy to do a stream, because usually you guys ask some really good questions that help in at least my own understanding, and I believe the understanding of other people as well. So here, for example, is a convolution with a square and a triangle, and you see it kind of goes down. Had I known that this visualization was already available, I would have just used that instead of making my own. But you see that here, the Y3, which is your convolution, is quite different in this case. So it really does depend on what you read in and stuff. Okay, so what do we have here? The output is shifted if both the kernel is linear phase and magnitude response is 1 anywhere. The signal is non-zero. If you have a kernel that's either 1 or 0 for all frequencies, linear phase, and the signal is the same, then the output is just shifted. For finite kernels, these conditions can only be fulfilled by pure impulse or periodic kernel. You're observing the central limit theorem at work. What is the central limit theorem? I'm sorry. Convolve boxcar with itself enough times and you get B-spline basis functions which converge to a Gaussian in the limit. What is the... oh, no, so if you combine two boxes, you get a triangle output. Yeah. So you're saying if you combine enough boxes together, you'll eventually get a Gaussian? That's interesting. Okay. So let me go back to what we were doing before with X and Y, because again, this still didn't work. Okay. And let's see what I'm going to do next. I'm going to run to get the error message again, and we're just going to start knocking it out one step at a time. Include main, and this will break at 3-element array, and this is on line 75. Oh. Okay. So this is where the residual sum. So the issue is signal 2. The index of signal 2 for some reason is 0, even though we're adding 1 to it at the end. So that means index modulo length of signal 2. So what is index? Index is going to be j minus I. So j minus I. Let's just output everything here. Let's just do print line and see what we got. So print line. And we're going to do index, which should just be I minus j. And then we're going to do... Actually, I think we just need the index. Should be fine. So let's go do main. Sorry. Include and then main. Okay, so here the index is going to be 4. 4 modulo 3 plus 1 is definitely not negative. Wait a minute. I got to think here. The index is -1. So -1, I see what's happening. Right. So for some reason, we're dropping into the negatives with this index. So that's the issue. We should never be dropping into the negatives. Ebo Dalum, I guess. Datum, thank you so much for following. Really appreciate it. With n boxes of the same size, you get uniform b-spline basis functions of order n. I see. Or, I don't know, they count the orders for b-splines, but you get the idea. I guess. So maybe I don't get the idea, though, because I don't know what a b-spline is. I'm sorry. There's a lot of things I don't know that I should. Sorry about that. I mean, for simple boxes, it counts order 0, I think. I see. Okay. So the index here is going less than 1, as I suppose it should, because if j minus I is less than 1, the index... Oh, I see. Here we're saying the index is going to be the length of signal 2 plus j minus I. I think this is where we're failing, because we say if j minus I is less than 1, then we say the index is going to be the length of signal 2 plus j minus I. But actually, in fact, that doesn't really make any sense here. So I think we're going to have to... Oh, there has to be a better way to do this. I can think of how to do this with while loop. But the issue here is that signal 2 is way, way smaller than signal 1. So if we have this kind of like 3-element filter that's just kind of moving around this way, we're going to have to keep finding the new indices for j. So let's see. So index is going to be j minus I. Right. So I need to find a new way to do this calculation. So if j minus I is less than 1, which means our index is too low, then we're going to say length of signal 1 plus j minus I. Length of signal 2 plus j minus I. I could just keep adding the length of signal 2 to j minus I until it is greater than 0. I could do that. We could do a while loop in here. Maybe that's what I do for now, but there has to be a more intelligent way to do that, I would say. So what I might do is I might do plus j minus I modulo the length of signal 2, and I think that's probably the correct calculation. Okay, let's just try this. Include again. Now we're going to try running main. It is running. We are getting something out. Is it what we want to get out? I have no idea. Let's learn together. Okay, so here's a triangle way. Ooh. Hey now. Okay. I'd buy it. Okay. So we have a triangle wave that's moving through. I reckon that's about right. Yeah, I reckon that's about right. We are getting nothing. We're nothing in the purple zone. Our convolution, there's just nothing being output. But we do have the little triangle thing moving across. So that's kind of nice, you know, in a way, in a sense. Okay. Oh, also, I think I figured out what I did wrong before. Okay. Yeah. Okay. So before our... Okay, I understand now. Because we're normalizing x properly this time, our Gaussian is going to be slightly smaller than it was in this visualization here. So what I might want to do really quick is just generate that visualization again that we have up there. Paste, and we're going to say y is equal to x. Comment this out. Just to see what it looks like after normalizing x and y correctly. So we're going to include, run main. There's... Right. Probably should stop printing line. So maybe remove that. And remove that. And I think remove... That should be fine. I think we want that one. Okay, like this. Now we're going to do the last mirage and see what we got here. Okay, so here we have these guys. Right, so that's exactly what I feared. We're going to have to... Yeah, the convolution is just way bigger. So we have to... we're going to have to, like, renormalize it a bit. So let's do that. So let's see, we have the normalization function that we can read in here. I mean, simple box counts as order 0, print line. Wait, I mean, there's nothing wrong with a print line. Print lines are fine. So the normalization function is going to, normalization factor is going to be the sum of x dot times x. I believe this should be x dot times y. Oh, that only works if x and y are the same size, which is not always the case. Okay, so we're going to have the sum of x dot times x, which should be the biggest possible value. I do not know how to pronounce that name. Bucephalus 01 Gold. Thank you so much for following. Really appreciate it. I hope you're having a great day. Okay, so convolution plot xy, norm factor is going to be equal to that. Seems to me, wait, the largest convolution, the largest value for the convolution output should be x dot times x. That should be correct. So then, you know, maybe I don't want to normalize x and y. Let's remove these comments. Maybe we just don't actually want to normalize x and y. Let's just do include. Let's just do main. Let's just give that a go. And then we're going to take a look at that. It's going to look better, and we're going to feel better about ourselves for about 2 minutes in time. And then we're going to hate ourselves again, because that's the nature of programming. Okay, Sim is embracing his inner fractal. Yep. How are you, that your fan? I hope you're having a great day. Okay. So now we're going to try with the smaller y again. Over here, write that, go over here, and we're going to run include main one more time. Now, the next bit that we have to figure out here is why our convolution sucks. So, image is going to be convolution, where are we? Mirage this. Okay. So we move this across. We should be finding some purple somewhere, but the convolution values are just not increasing. Which is weird to me. So let's just see what we're getting here. Okay. So we have the signal plot here. We have output I. What I'm going to do is output rsum here. So print line rsum, write that. And we're going to do include main. Okay, we are getting stuff times 10 to the negative 10th the whole time. I don't think any of these guys were larger than that. So let's just print line. So we're going to say if rsum is big, then we print line. What was that? Convolution linear. Wait a minute. Why do I have two separate convolutions in here? I have one for plotting and one for just basic convolutions. What was I doing? Like, under what situation would I write the same function twice? Why am I so dumb? Okay. Could it be the values just so small it's not visible? That could be the case, but also it doesn't really make too much sense that would be the case, because the convolution should be a sum of the two elements multiplied together. So, for example, we have 1, 2, 1 as our kernel that we're reading in, right? So if it's going over a Gaussian, the Gaussian has to have some finite value there, which we'll say is like 0.5. And so in principle, the convolution should be of size, you know, you would say 0.5 times 1 plus 0.5 times 2. So 0.5 times 4. So it should be of size 2-ish at its peak, I would say. But right now we're getting nothing. So that means that our convolution is clearly just not working. So I'm going to keep working on the convolution plot right now, because that's the function that we're actually using here. And then we're going to come back to fix the convolution linear, because apparently I'm dumb and I don't know how to code. So that's okay. At last I managed to catch you. Hey, how are you, Martin? I hope you're having a great time. Let's see. What I was going to say is I am definitely, like, I've mentioned this all year. And all year being the last 3 days, because it is, of course, the third day of the year. But I am genuinely going to be doing what I can to do longer streams so more people can catch me and stuff like that. But also, I am trying to maintain some form of work-life balance this year. It's just I don't know how to put it, but my work, how do I put this? Okay, so work is for the next 10 or 15 days, just working on online content. my life is not really existent because, again, my girlfriend's still in Okinawa and has been for the past year, and I haven't seen her in a while. And I mean, my roommate's upstairs. I could talk to him, I guess. But like, mainly my life involves just kind of like sitting and planning different projects that we'll work on throughout the year. That's kind of like what I've been focusing on, doing that and a bit of creative writing. I've still been doing a lot of writing. My secret nefarious plot to become an author is still, still there, still a big plan. But yeah, as far as like longer streams and like catching my stream and stuff like that, you can expect starting the next week or so, I'm gonna start ramping up my stream content, and that's kind of the plan. Pandemic living. Quite frankly, I don't think I ever had a life, so the pandemic didn't really change what I did that much. It just, I don't know. I just got shook up this past year. Like, it was just kind of a hard year. So I don't know. I'm just hoping that 2021 brings a lot of good tidings. Good tidings, I think, is an unofficial phrase. I think that's okay. Okay. So our residual sum here is always basically 0, which isn't great. So let's see. Signal 1. Okay. Let's just go ahead and just mess with this a bit. So what are we doing? We're saying for I is equal to 1 to n minus 1. So we're just iterating through every single element in I. And I, in this case, is going to be the output convolution image. Okay. So then we're output convolved image or output convolved signal, whatever you want to call it. I think I just got something. I'll be right back. I actually just got a package, I think. So give me just 1 second. Sorry about that. Okay, I'm back. Sorry about that. My roommate was here. I didn't realize he was here. So he picked it up. Okay. Right. So, for I is equal to 1 to n minus 1. This is actually not going through the time domain. I'm just going to modify this because these comments make no sense. So this is going through the convolved output. Okay. So what is this going through? So j is going to be 1 $$ here. Will be a while till I have math classes to really understand, but I love this stuff. I appreciate that. I mean, like, yeah, we're going through as fast as we can, or like as detailed as we can. And the thing about the stream is it's not so much like me teaching people like this stuff. It's more like us learning together as a community. And I think there aren't so many streams out there that do that. I mean, there's some streams in science and tech, obviously, that do that. But like, I don't know. I feel like we have something special going on here. I don't know if it's an L or an I, but Mac user, thanks for following. Really appreciate it. Okay, so here's going to be the convolved output. It's just going to go from 1 to n minus 1. Should be fine. Okay, now we're going to say for j is equal to 1 to length of signal 2. So that's going to be going through the filter. We're going to say if j is less than the length of signal 1. I don't know why I came up with this logic. I'm going to have to like redo all of this at some point. See, this is the issue. I make this code like... I made this code like a few months ago, if not a year ago. And then I'm now trying to decipher what I wrote. And a year ago, I was like, well, I'm going to make an algorithm archive article about this. So it's totally fine. But I did make the algorithm archive article. And then I removed the algorithm archive article because it wasn't good enough. And so now I'm rewriting it. And I'm trying to decipher what I wrote back then. So it was my fault for writing bad documentation a while ago. Okay, so we're going to say for j is equal to 1 to length of signal 2. So that's going to be going from 1, 2, and 3. So it's just 3 inner elements. And we're going to say if j is less than the length of signal 1, which it always will be. But I guess we have to make sure we have that check. We're then going to say the index is going to be j minus I. Okay, so we're going to iterate through. Seems fine. Say algorithm archive article 5 times fast. Algorithm archive article, algorithm archive article, algorithm archive article, algorithm archive article. Okay, fine. You're right. I shouldn't have done that. So we're going to say for j is equal to 1 to length of signal 2. We're going to say index. Now, what is this an index of? That's my question. It's an index is equal to j minus I. And then we're going to say if j minus I is less than 1. I got 4 times through. You know, it's pretty close to 5. The index is going to be length of signal 2 plus j minus I. I think this is just an index of... Yeah. Okay. So here, let me explain what I think we're doing. So, okay. So what we should be doing, and of course this is maybe not exactly what we're doing, but this is what we should be doing. I'm going to draw a little coordinate system in here. And so we have our Gaussian, which, again, I'm just going to pretend I can draw just for a second here. Here is our Gaussian. All right. Not so bad. Could be better, but, you know, it's okay. 4 is equal to 1, basically. 4. Oh, I see. 4 equals 5, up to a constant. That's fair. So then we have this triangle wave that we're sending through. So here's our little triangle wave. Again, it's like 1, 2, 1 or something like that. And we're sending it across this way is what we're doing. So what I should be doing is I should be iterating through like 1, 2, 3, right? And then I shift it over by 1, and then do 1, 2, 3 again after shift it over. And then I shift it over again, and we do, 1, 2, 3. So the idea is we have an inner index, which is going to be j, and an outer index, which is going to be I, and we're just kind of shifting it through and doing the multiplication at each step. There's probably a better way to do this, I believe. So for I is equal to 1 to n minus 1, then we're going to say for j is equal to 1 to length of signal 2, what I'm actually going to do here is I'm going to comment all of this out, and we're just going to make our own convolution again, because clearly I don't know what I'm doing. So we're going to comment that out. Oops, sorry about that. And we're just going to try it again. Yank and paste here. Well, DDP. Okay, so let's just go. So here we're going to say for I is equal to 1 to n minus 1. I actually think we're broken at this stage. I think it should start at n minus 1. Go in iterations of -1 and go to 1. I think that's what it should do. End here. And then down here we're going to do signal plot. I specifically read an I there? Okay, whatever. Of I, signal 1. 1, signal 2. And then the output. Okay, so in here, I believe, we're going to do 4. J is going to be equal to 1 to length. In fact, we can probably just do an image offset here. We probably don't have to do anything crazy. We already have I, which is the iterable index. So now we just have to find the indices of the triangle wave that we're moving through. Now, I think the reason it was so complicated before is because the two signals were large, and what I was trying to do is I was trying to make it so if like the orange line was sufficiently far over to the left, it went back around to the right. Doesn't matter which way you loop, as long as your indexing scheme is consistent with your looping direction. That's probably true. Okay, so we're going to say I is equal to n minus 1, minus 1, 1. Well, okay, it does actually matter which way you go, because that's the difference between a correlation and convolution, I thought. Yeah, that should be. Anyway, let me get some water. I need to think about it again. I'm drastically behind on my understanding of these topics. I should be way better, but I'm not because I'm dumb. Okay, so let's do 4j is equal to 1 to length of signal 2. Oh, 2. And let's just go 1 to n minus 1. Just why not? Okay. So this is going through that signal, and then we're just adding to the residual sum, and then we're outputting that at the end, and then we have our indexing in there. Archive question: I don't see a rule against a rule or something against using it, regardless if it's silly or not. But do y'all accept Wolfram Mathematica code? We do not. Yeah. Well, wait, no. Wolfram Mathematica code. No, we do. I'm sorry. I thought you meant code from Wolfram Alpha. But if you mean code that is in Mathematica, that's totally fine. Yeah. Sorry, I misunderstood what you said. Yeah, that should be fine. As long as you can get someone to review it, it's totally okay. We accept any language. It's just the main issue is that we need people that know those languages to review those languages, right? So if you implement Mathematica code and you want to get your buddy that knows Mathematica code to help review it, that'd be great. That would help out tremendously. So, okay. So we're gonna go length of signal 2. What are you doing? Stop highlighting that. Okay, so we're gonna say j is equal to 1 to length of signal 2. Okay. So in principle, all we need to do, and this is just in principle, it's not exactly what we need. So we're going to say residual sum is going to be plus equals, and it's just going to be signal 1, 1, I see. Okay, I understand what we're doing here. Signal 1 of j, where j is the inner index. Actually, why is it of j? Why did I have it of j down here? That doesn't make very much sense, does it? Anyway, we're going to say signal 1 of j, j something. I think it's going to be I plus j? Or I minus j or something? Let's try I minus j. And then we go from there. I think Mathematica is what I'm going to guess MMA stands for. Probably not mixed martial arts. Because it'd be very weird if he was... Yeah, okay, that's fair, right. Because, I mean, MMA could also stand for mixed martial arts. And, like, look, if you can implement an algorithm in mixed martial arts, do it. Like, I'd love to see it. That'd be interesting. All right, let's just keep going then. I'm sorry. So we do the residual sum is going to be signal. So what I wrote before was this the signal of j. Oops, sorry about that. Times signal 2. 1 second. Now this is where I think things got wrong. I think this should be signal 2 of j, right? And then we should just be shifting it based on what I is. So should it be I? Can't we just do the following? Can't we just say our sum is going to be equal to the sum of, and just hear me out here, signal 1 of I. Okay, I see where this gets confusing. That's totally fine. We'll work on this in just a second. But in principle, we can do the following. We'll say I 2 length of signal 2 minus 1, something like that, dot times signal 2 I think it's just dot times signal 2 should do it, I believe. Sure. And then I think we can remove this guy, and then we do that, and then we reset our sum equals 0 down there. That should do it. Let's see, what do we have here? That'd be really cool. Relay integration via interpretive dance. That'd be interesting. Chaos game with explosions. Well, we'd be sole contributor buddies. Hopefully not for that long on my language, but who knows? I'm sorry it takes so long. Like, that's one reason why I really do need to start making more online content, because it's just taking too long to do the reviews. If we have more people in the community, the reviews get done faster. As I understand it, J is iterating over signal 2, I is iterating over signal 1, so you should be indexing signal 2 by J. Yeah, that's what I think as well. If it is meant to be a convolution, it is. Also, thanks again, Trash Talk, for the review. Yeah, thank you guys so much for the review. Trash Talk has been doing more reviews than anyone else, but, like, obviously this is a community thing. Like, it takes a lot of, like... The only way for the project to work is if you have people like who are willing to take part and help out. And that's just how it is. So, okay. So then this in principle should do something. So let's just see what happens if we include. Maybe? No? What? I thought that works. And then this should also work. That should work. Huh? What's the issue? On line 67. Oh, I forgot a comma there. I see. Try it again. Main. All right, we're doing something. Don't know if it's working, but we're doing something. Bounds error. Attempt to access a 100 element array at index 99 to 101. I see. So this only works for n. I see. That's why we were doing the other indexing. Right, perfect. So then let's actually take a look at the images that we did create. 001. So we should see... Okay, that still didn't work. Unless we didn't actually output any images. Let's just remove all of our output images and run it one more time just to make sure that we were actually outputting something. So remove out star PNG. What? LS? I see all those out star PNGs and it said I couldn't remove anything. So let's just quit here. And let's just do remove out star PNG here. And then we're going to go back over here and we're just going to run main. ls here. Okay, it does seem to be outputting stuff. So now if we do mirage out whatever .png and we scroll down, yeah, okay, so it is moving across, but it still is not outputting what we'd expect for the convolution. Totally fine, we'll figure it out. Okay, let's go here and let's keep going. Let's see. Thank you for the review. Wait, what? I've done 2 this year, so I wouldn't call them a lot. Yeah, but we've been doing so few reviews at this point. I can't review my own code. That's basically the point of a code review. I'd be down to review coconut code though. Is convolution the area under the overlapping part? No, it is not the area under the overlapping part. Sorry about that. Just be clear, it's not the area under the overlapping part. And that's a very common misconception of the convolution. It's the area under the if you take the 2 overlapping parts of the signal and you multiply the 2 overlapping parts of the signal, and then you sum the area under that, then you get the convolution. That's see that's the false statement there. The area under the overlapping part is the value of the convolution at that point. That's false. So like for example, the convolution at this point here, that Gaussian, that is the convolution, is not the area under the overlapping part, right? It's the area under the multiplied, like these 2 guys multiplied together, right? So it's like you multiply the overlap and then you integrate that. It's one of those things that like it's super misleading if you like read the Wikipedia article on a convolution. It's like it's really misleading, which is why I make sure there's a point. Like I make sure I make a point about that. No, don't be sorry. Like obviously, it's just that that's something like if you read the Wikipedia article, because of the specific examples that they use, it actually gives people like it really does mislead them down that direction. And for me in particular, kind of hurt me and my understanding of the method. And so I was unable to implement it for almost a month, honestly, because I couldn't figure out what it was doing. And then I ended up just doing the convolutional theorem because at least I knew that would work. And it wasn't until I realized it's not just the area under the 2, it's the area under the 2 multiplied together. And I was like, clearly that's the case, but it's just the examples that they provided were kind of a bit misleading there. That's all I wanted to say. That's also true, right? Maybe of course, I'm being a bit pedantic as well. Let's see. So let's just keep going here. I'm clearly doing something dumb. Thank you guys so much for noticing. Let's just do the plot down here. Blah, 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 blah. Okay. So we're just going to keep knocking this out. Let me see what the residual sum is. In fact, let's just go down here and let's just say y is equal to this as well. And let's comment that out. And then let's just do this. So we're going to do Mirage. Oh, sorry, include. And then we're going to run main. This should break. Error attempt to access 100 element array at index 2 to 101. Yeah, of course it does. Tim, how are you? Thank you so much for the raid. Let's see. I thought we were referring to the shaded region below the overlap. Yeah. So, Tim, let's see. What is up? I hope you're having a wonderful day. Right. How are you doing? How was stream? I saw that you were streaming, but I didn't see what exactly you were streaming. So for those of you guys who don't know, Tim is a wonderful streamer. He's usually in the science and tech category. He has made a racing game called Rally of Rockets. And he's also been doing a whole bunch of other stuff recently. Actually, again, it's been a long time since I caught up on a Tim stream. Sorry about that. I've just been so busy. But yeah, feel free to talk about how the stream was. If you guys don't know him already, please feel free to go and give him a follow. He's just a cool, chill streamer. I think you'll enjoy the content. Goofy Lagrangian, can you please repeat? I'm now even more confused. Yep, sure. So, right, so what is a convolution? I'm going to pause at any point here. So, essentially, the convolution at every point, so for example, this point here, is going to be the integral under f times g, right? So you multiply f and g together, and f is going to be the blue, and g is going to be the green. So you multiply them together, and then you get this additional function here. And then you integrate that other function, and then you get the convolution. So essentially what you're doing is you're taking one filter, and you're moving it across. And then at every point, you then multiply f and g together, and then after multiplying f and g together, you then get some convolutional output, and that's what the convolution is at that point. So I'm sorry I'm doing a very bad job of explaining it. I promise I get better the more I try to explain it. That's just how it goes. Had a great day. We did a lot of stuff, but I got to jump off for now. Thanks for the shout out. Yeah, thanks for coming in. Really appreciate it. I'm glad you guys got a lot done. Tim spent the day writing telemetry overlay for his racing simulator. Let's see, what do we have here? Lana Lux, hey, thank you so much for the raid. Really appreciate it. 3 raids in one stream. Yeah, we got a lot of raids today. So F times G is a Gaussian looking thing, and then you integrate it. Yeah, Lana, how are you? It's been ages. Well, not ages. I just watched your stream the other day. I don't know why. I just lurk in your stream all the time. But for those of you guys who don't know Lana, she's a cool game developer. Like super chill streams. I think, you'll really enjoy the content. Definitely check her out. She's really cool. And yeah, I guess I don't really have much more to say. What were you working on today? Last time I came in, you were working on like modeling and stuff. But yeah, what were you up to today? Let's see. Jin-san, thank you so much for following. Really appreciate it. Okay, so, right. What do I do here? Hello, my name is Dr. James Schloss. I got my PhD a year ago, and I've just recently stopped working at MIT, which is, I mean, everyone knows what MIT is. Anyway, the point is, we're working on a project known as the Arcane Algorithm Archive. It's just a place to put as many algorithms as we can in as many languages as possible. So right now we're working on the convolution chapter for that, which will all build into a project where we eventually will turn any image into a fractal. So let me describe what that is in just a second. Let me catch up on chat, and then we'll go from there. So, got it. Thank you. Telemetry seems cool. Any message from Voyager? Out edges solar system. Oh dear, has it been a year already? Today I was splitting the game into different scenes. It was a headache, but made some progress. That's every day, right? I mean, like, anyway, I'm glad you got some work done. I feel like convolution is a bit easier to understand in discrete time, where the value at the sample n is basically an inner product between the signal and the kernel shifted by n samples. Right, so that's what we're trying to implement in code. I'm just failing at it. Convolution is big neural nets. Yeah, that's true too. Show me your fractal. Yeah, I'll show the fractals right now, actually. So right now what we have, ooh, hello there, 1 second. CD projects, Simuleos. In fact, let me go to the algorithm archive first. Algorithm archive, L is here, CD into contents. What am I doing? Just 1 second. I need to think. It's really hard. Contents, iterative function systems, L is here, CD resources, and then if I just do MPV, and I think I want to do, is there a Sierpinski-Hutchinson? There's an MP4 video. I guess probably IFS triangle vid. Let's just do MPV IFS triangle vid and see what this does. Maybe I need to look somewhere else. Yeah, I do need to look somewhere else. Yeah, okay, wrong visuals. Give me a second. Let me try this again. CD videos, algorithm archive, iterative function systems, L is here, and then I should have it, Sierpinski-Hutchinson. So let's do MPV, Sierpinski-Hutchinson.mp4. Perfect, this is what I wanted. Okay, so the heart of the fractal method that we're working on, it's a long time. This is very unrelated to convolutions, but I'll explain how it all comes together in just a second. So just bear with me. I'll catch up on chat in just a second. Lana Lux, some days are more fun than others. Yeah, but it's okay. I mean, I'm happy that you got work done, though, Okay, so the heart of the fractal method that we're working on is something known as an iterated function system. Essentially, what you're doing is you're iterating through function systems. So, for example, if you have 3 points, A, B, and C, and 3 subpoints, D, E, and F, and you create 3 functions, one of which will bring you halfway towards A, another of which will bring you halfway towards B, and another of which will move you halfway towards C. You can then iterate through these functions to basically create, children that move in those directions. So you have 3 moving towards A, 3 moving towards B, and 3 moving towards C. You can then keep having these children generate more and more children until eventually you start to see a fractally pattern. And in this case, this particular function set creates the Sierpinski triangle, which is something that a lot of people know. It's like triangles within triangles within triangles. So using that concept, we can then combine a bunch of different systems, iterated function systems together into something known as a fractal flame, which I will show you now. CD projects, Flamify, L is here, and let's do Mirage check.png. Okay, so this, for example, is a set of different fractals put together. It's kind of like a sinusoidal fractal, which creates this little hole in the middle, mixed with like a swirl fractal and a heart fractal. So we can create images that look like these. Again, these are just kind of 2 different function sets. And now you might be asking, where does the convolution come into play? Thank you so much for asking. That's a very good question. So it turns out that the way you generate these fractals is by creating a very large set of points that all act accordingly, kind of like you saw in that video before. And so the convolution is useful in these places up here when you have very few points, and we kind of smear those points together. So we use a convolution to kind of blur it at this region. So that's why we're taking a step back, learning about convolutions, and then we're going to do affine transformations next, followed by the fractal flame method, and then genetic algorithms, put it all together into this big project that allows us to turn any image into a set of fractal flames. That's the goal. We'll see how far we get. Now let me finally catch up on chat. I'm so sorry that I missed chat for that whole time. There we go. Feel like convolution's easy to understand. Show me a fractal. Some days are more fun. What language are you writing in? Julia, let's see. Looks like Java. Maybe in some ways. Have a good meal. Yeah, see you, Lana. Have a wonderful time. Let's see. Time to get groceries. I think... Julia, usually I've seen a Triforce, all the better K-Cups and cinnamon. Follow time for bed. I'll be back. Love math. See you, Jonas. Appreciate you coming in. MP, I'm going to pretend I understand what you're talking about. Yeah. Well, thanks for being here anyway. And also, if you guys have any questions, comments, concerns, ideas, anything like that, just feel free to let me know, and I'll totally address it as soon as I see it in chat. Let me go ahead and follow up on the follows here. I already said thanks for following Jinsan, but also Echo Streps, Vidor BGS, Jonas, Red Mage Panda, and Woho Haha. Thank you guys so much for following. Really appreciate it. Understood nothing, but I followed. Well, thanks for that. I'm going to do my best to explain things. I'm sorry, that was like a really quick, very quick explanation of what this is that we're doing, but there's a lot to it, you know. So I'm hoping that, again, if you guys do have specific questions, you'll ask, and I can do what I can to answer it. Ambi Dragon, thank you so much for following. Really appreciate it. Could you give me some advice about something? Yeah, go ahead. I'm happy to advise on anything I can advise on. I don't know if I actually have the, the ability to answer appropriately, but I'll do what I can. Okay. So that brings us to convolutions. And we can go from there. 200 IQ and counting. So that is function math. I have a candidate for the algorithm archive. Cool, yeah. Feel free to. You can even create an issue for it if you want. Yeah, I guess it's function math in a way. What does it mean to turn an image into a fractal plane? Is it some kind of image compression? That is a good question, and it is also kind of unrelated to my plan, but there is this thing that's used for image compression that is fractal-like. So fractal image compression is totally a thing. Fractal compression here. I've been wanting to do it for a while, but for now, let me just paste this in chat and say this is somewhat related to the thing that you're talking about, but maybe not directly related. The question of what does it mean to turn an image into a fractal plane, we're not dealing with fractal planes here, unless you talk about the affine transformations, but really we're not talking about fractal planes. We're talking about a different type of fractal that is generated via the iterated function systems. So, going through the theory of convolution just to blur an image seems like a fairly pedantic approach. Not that I object, just observing. So the reason we're doing this is because, again, we already had convolutions in the algorithm archive, and the plan is to just revamp that chapter. And so what I'm trying to do is I'm trying to combine all the chapters together, right? Because, again, we're trying to provide a learning resource, right? And so if you're going to learn about fractal flames, you need to learn about convolutions in order to understand how to do that part, right? And so that's kind of the idea. We want to give people everything that they need to know, so if they see a fractal flame implementation, they can then go through each part individually and go as far back as they need. Now, one thing that we aren't covering with convolutions is a convolutional theorem, which is a way in which you can do convolutions via fast Fourier transforms. We'll be doing that later when we're updating the Fourier transform chapters. The defunctional fam jam and also Ambidragon, thank you guys so much for following, really appreciate it. Those things we learned on undergrad. Funny is that now I remember none of it. I did this implementation a month ago, and I'm really just trying to remember what we did. I remember none of it. How to stop procrastinating and start studying. I mean, I guess at some point, maybe this channel is studying, but I don't know, like, maybe I'll talk about it in just a second. I should really go to sleep, but I'm hooked. Well, thanks for being here. But as far as like studying and stuff is concerned, I'm going to tell you one site. There's a particular site that I'm no longer addicted to, but I wish I were still addicted to. It's called the archive.org. Used to be every single day during my PhD, I would just go here to computer science new, and also a lot of the physics and stuff as well. And I just browse and I just read papers, and that's what I did. And I loved it. I loved it so much. Even now, like as I'm reading these titles, I'm like, these are super cool. Like, you know, deep learning towards edge computing. I'm not super into neural networks, But when you talk about compressed data, all of a sudden I'm into it, you know? So like, it's just, there's just a whole bunch of papers that come out every day from like really intelligent people. And it's just filled with like, all this amazing research. And like, in terms of like, you know, how to stop procrastinating and start studying, my solution to that was to never study to begin with, but instead just to learn and learn for fun, you know? So like, you know, if you have to study for school, that's fair. You have to study for school. You have to get it done. But there comes a point when it doesn't have to feel like studying, right? Like it could feel like just learning, and learning is genuinely fun. You know, every time you play a game, you're learning about how the game works. Anytime you read a book, you're learning about how the universe works. It's learning, just it's disguised with this other layer of interestingness on top. So if you just remove the school aspect and you just focus on the learning aspect, it's actually quite fun in my opinion. I don't know if that was helpful or not. I'm sorry. I wrote some codes to calculate curvilinear motion in Python, calculate XY point in custom time, overall flight time of a mass start, flight from custom height, etc., but want to visualize a projectile. How can I do it with Pygame Turtle or something else? Okay, let me just... 1 second. Okay. I wrote some codes to calculate curvilinear motion in Python, calculate XY point in time, overall flight time of a mass start. Okay, I see. So essentially you have a projectile that's moving and you want to see how to visualize that. You can use any plotter and plot it out as a series of PNG images for every point in time, and then you can concatenate those all into a video. That's what I do with FFmpeg. So like, for example, just use pyplot or matplotlib and just plot the point at every point in time, and then at the end you'll have a whole bunch of images, and then just save those images as a MP4 file. So like, just do ffmpeg -i, you know, image whatever .png, and then output.mp4 or something, and it should work pretty well. The Taurus Donut, nice name. Thanks for following. Just got a copy of Papa Dimitrios, I don't know, computational complexity. That sounds super cool. I've got 20 minutes until compilation finishes. If it passes, I'll finally be able to sleep. Pretty good motivation. Oh man, I've been there. Jokes on you studying. I enjoy this subject. I attend computer science at college, and I find studying extremely boring, although I love the courses. What's your favorite kind of yogurt? My favorite kind of yogurt? I don't usually do yogurt too much, but I guess blueberry if I had to say. As far as like studying is incredibly boring, yeah, I agree with that, but there was something else. So, Irmitinkan, I'm sorry if I'm mispronouncing that, but like, what was it? I used to spend hours doing nothing but compiling wine. I don't know if anyone else has had this solution, had this experience, but compiling wine, so wine emulator, I guess, it stands for wine is not an emulator, but wine software, right? So like, for those of you guys who are on Windows or on Linux, a lot of times you have to run code or software or games that are made specifically for Windows. And a lot of times to do that, you have to use this program, which is called Wine. And a lot of times I found myself not really enjoying playing games, but really enjoying compiling Wine. I don't know what the deal was, but I loved just like patching it, compiling it, trying to figure out which patches work best for what game, and then just like sending it to Wine HQ and being like, yeah, that's the best way to play Guild Wars 2 with this set of releases and stuff like that. You know, that's what I did. I spent hours and hours doing that. It was super fun. And then I didn't even play Guild Wars 2 that much. I was like, it's okay. I got my fix. You know, it works on my machine. Let's move on to the next game and try to get that to work. Matplotlib and FFmpeg then, thanks. I'm going to give it a try. Yeah, see if that works. It's the simplest solution, but if you want something more complicated, like you can go as far as OpenGL, but like I wouldn't. It's too much work for something like that. What do I have? My home engine now specifically to check the I don't know what that stands for. I'm trying to introduce so much constant expressions. I see. Constant expressions into GLM and possibly besides developing my engine. I use Play on Linux to do much of the installing work. Yeah, how different is MIT from OIST, academic culture-wise? MIT, that's a good question. So for those of you guys who don't know, I did my PhD at the Okinawa Institute of Science and Technology. Also, yeah, I am rambling. I do totally understand that I'm rambling. We'll get back to doing work in a bit. Sorry about that. So let me just go to admissions.oist.jp, because I think this is usually the best site to go to. So yeah, I went to the Okinawa Institute of Science and Technology for my graduate studies. It was amazing. Loved OIST. It was amazing, and I wish I was there now. That isn't to say MIT is bad. It's just that OIST was like perfect for me. Now, when it comes to the difference between OIST, which again is a relatively unknown institution in the middle of Okinawa, to MIT, truthfully, the like hardware and software we have at MIT is not as good as the hardware and software that we had at OIST. Like we had better stuff at OIST available. That isn't to say MIT stuff is bad. It's just saying that like the OIST stuff was top of the line because they put a whole bunch of money into the project, so we had top of the line stuff. Culture-wise, it's not too different, except that MIT is a little bit less diverse. It's more of a white male place, whereas OIST was more for a diverse set of students. And really, in terms of like just the academic research that's being done, I reckon it's about on par. It really does feel like it's about the same as OIST was. So it really isn't too much different, in my opinion. OIST and MIT, they seem about the same. That's about it. I'm sorry, I don't really have much else to say besides those three things. What do we have here? I know, but I find myself going back to playing Linux more because of Lutris. Oh, more often than Lutris, right. Wait, I missed a lot here. A lot. Let me go ahead and catch up on chat. I use Play on Linux, right. So the 20-minute compiler evaluating constant expressions. Lutris is worth checking out. But thanks for all of you who do the testing. How's the weather in Okinawa? Weather in Okinawa was nice. I mean, you have the occasional typhoon, which is essentially a hurricane, which you have to deal with. But ultimately, it was nice. It was around 30 Celsius all the time, so it wasn't stupidly hot. But it also wasn't. It never really got that cold. So I actually like Boston temperature better than Okinawa temperature. I know, but I find myself going back to play on Linux more. Nice, actually, there are multiple targets, debug release with whole async library and few others. I never measured what it takes to what takes so much time. Usually I don't need dry compilations. What about academic rigor, qualifiers, expectations from grad students? So you speak Japanese? 少し日本語わかります。僕の彼女が日本人です。ごめん、でも僕の日本語が悪い。So do I speak Japanese? Very little is what I said. My girlfriend is Japanese, but my Japanese is still pretty bad. That's what I just said. Did you also study karate in Okinawa? I did not, but a lot of people did. As far as academic rigor, that's a good question. In terms of the rigor of the research, it feels about the same. In terms of the rigor for the students, I feel like MIT is probably a bit more rigorous for students. That is to say, I feel like the classes are a bit more rigorous, and I feel like the exams are a bit more rigorous. But I feel like the research that is done at the end of the day feels about the same for both places. Now, again, I can only really talk for the places that I went or the type of research that I did, which was in computational physics in this area. So I can't really talk beyond that. But I will say for the areas that I went to, it's about the same. Understood Nihonjin? Soka. I need to learn more Japanese. So I just had a call with my girlfriend's family, which I'd never done before. So it was really awkward because they were all on Skype. There was like a huge Skype group. And, you know, the moment I come in, everyone starts asking me questions. And I'm like, oh, no. Is there any aspect of the Asian culture that rubs off in academia in Okinawa that might not be at MIT? The answer is no. But there is probably an aspect of European culture that rubs off in academia in Okinawa. Specifically because the Okinawa Institute of Science and Technology was largely international. So it wasn't just, in fact, there were very few Japanese students. So for the most part, sorry, I just got some notifications that I had to look at. So for the most part, it wasn't so much about Asian culture at all. It was pretty much all just like international folks. Europeans were probably the largest group there. So I don't know if that's good or bad. You went there? Yeah, this is where I went for my PhD. I mean, again, like, so for me, there's a few reasons why I still wish I was there. It's not, MIT is still great. Like, MIT was great. I'm very glad I was there. But also, like, I was at OIST for 5-6 years, you know? And I loved it there. And, you know, there's the ocean, and like everywhere you look, there's the ocean, and like, you know, pools are still open, and because it's Japan, it's not as bad with COVID. But the main reason I want to be back there is just because my girlfriend is still there, and we haven't seen each other in over a year now, because we just haven't been able to arrange a trip. So, like, the thing that sucks is if I would have stayed in Okinawa for an extra month, if I would have just taken a month off between my PhD and my postdoc, I would have been stuck in Okinawa because of COVID. And then we wouldn't have ever had this time where we had to deal with a distance relationship. So like, again, it's just one of those situations. Noob Dude TV, thank you so much for following. Really appreciate it. Okay, so anyway, so that's, maybe we should get back to convolutions now, since we've done a bit of rambling. But again, if you guys have any further questions, I'm going to do my best to answer whatever questions come into chat. So feel free to ask whatever you want, and I'll do whatever I can to answer whatever comes up. Irmiticon, thank you so much for following. Really appreciate it. Let me get a little bit more water. Okay, so, right. We are failing miserably at implementing a convolution at this stage. Rather, it's not we. I am. I'm failing miserably at implementing a convolution at this stage, so we're going to try to get that done. COVID sucks. I hope you get to see her soon. I'm off to bed now, but I'll listen to the stream at the same time. Yeah, have a good evening. Simula rant over. I mean, I have this screen now for anytime I do a Rambleos session where I'm just like rambling. So just in case, you know, we need another ramble session, I do have this available for the future, but I really should not be using it. I should be focusing predominantly on the convolution content and stuff like that. So I want to get this visualization done for the 1D convolution, and then we might take a break, do some algorithm archive PRs. I'm not really sure. We'll see where we go. Okay. So what we should be doing, just for the record, so what is a convolution, for those of you guys who might be asking? Again, I said that we need it for the fractal flame method a long time ago, before the whole Simula rant, because I wanted to talk about, you know, why we need the convolution. So now what exactly is it, is the next question. So Simuleos is a PhD in the US fully funded. It depends on the field, but, sorry, for the most part, if you're going to do a PhD in a STEM field, science, technology, education, math, then it's probably fully funded. In fact, you probably get paid to go to school. So the stipend at Auburn University would have been $19,000 a year, so you get paid $19,000 a year to go there. The stipend at OIST was 2.4 million yen, which is roughly 20,000 US dollars. But also I had a special fellowship, so I was actually getting paid slightly more at 3 million yen, which is roughly $26,000. So it's not much, but it's enough to live off of usually in the places that you're working in. So like, for example, MIT's student stipend, I think is closer to $45,000 a year because it just costs more to live in Boston. So it's very much funding driven. Sometimes you could run out of funding and might end up doing GTA. Oh, so yeah, TAing is also fine, graduate teaching assistants. Was it anything like the Fellowship of the Ring? It was very different than the Fellowship of the Ring. You know, you still have that, you know, you still have the ring, right? You're still looking for this one little piece of research that completes you and all this kind of stuff. And, you know, you still have to throw it into the fires of Mordor, which is, you know, the publication at the end. But for the most part, you know, when you're giving up the rights to the publisher. But for the most part, it's you don't have as many dwarfs to deal with. And you don't have to deal with, like, you know, any of the wraiths or anything like that. So I'd say it's relatively different than the Fellowship of the Ring. Boston rent is very high now. Yeah, rent is super high. Like, again, I've told this story plenty of times, but in 2020, I ended up having to pay for an apartment that was $1,800 a month, and it was just infested with roaches and mice and all this kind of stuff. It was pretty bad. And then I had to move in with my parents for 6 months after that because I couldn't live in that apartment during COVID because you have to stay there the whole time. And I still had to pay $1,800 a month for an apartment that was just, it was not worth that amount of money. Like, it was awful. Genuinely the worst living experience I've ever had in my life. I would not, like, you couldn't pay me money to go back there. It was awful. And I'm certainly not, like, there's a, you know, we're kind of deciding where we're going to go, in September. So the idea is in September, my girlfriend should have a new position. So I'll move to wherever she has that position at. And I don't know, I'm kind of dreading it because, she might stay in Boston, and just Boston housing is just the worst. I mean, I'm sure it's worse somewhere else. I'm sure there's worse housing conditions in California or something like that. But coming from Alabama, Boston is it's just way worse, you know? That's making me think that I need to pay my rent. Yeah, I mean, I just paid my rent the other day, I think. So, yep, you're welcome. Okay, So let's output this residual sum at every step and see what we're getting here. So let's just print line, print line, our sum. And let's just run this again. So, oh, this is failing. Right, okay, let's just do it anyway. Include G, move this over here. All right, so this is gonna fail, but let me just see what the residual sum is and see if this is actually doing what we expect it to do. So include main again. These, oh, it's doing something. It is definitely doing something. Wonderful, great, okay. So in that case, then we just have to figure out the indexing of the inner domain. Perfect. All right, we're getting there, one step at a time. Okay, so what are we doing here? So what is the convolution that we're looking at? So if you see this visualization in here, let me just make this big. You will see, I don't know, Boston rent might be worse than San Francisco. I want to say it is, but I really don't know. It's pretty bad. It's doing something. Coding, sorry. Isn't rent coming down due to COVID? I saw an article about folks moving out of NYC due to COVID. Yeah, I think so. Our particular apartment that we're living in right now, me and my roommate, was originally like $3,500. Yes, $3,500 a month. But we're only paying $3,000 a month, and part of that is due to COVID. The other part of that is just because the person that we're renting from likes MIT people, and we were both MIT people at the time. So yeah, that's basically it. So we're paying less than we would normally have to pay for this. But outside of that, I don't really know. Okay, so right, so what is this that we're doing? So first of all, what does the convolution do? So a convolution is a way to kind of merge or blend two different signals together. It's just another operator to add these two signals together. So what you're seeing here is kind of this this kind of green shaded region in here, which corresponds to signal F and filter G being multiplied together, right? And so that's what the convolution, the area under this multiplied output is going to be your convolution at that point, right? And so on the this little purple line here, you see is the convolution at that point. And so the idea is that we have the convolution is simply the sum of the multiplied output of the filter and the signal. So what we do is we take the signal and we keep it steady, and then we take the filter and we just kind of move it around and move it along, and we just multiply at every point as we're moving that filter along. So the issue that we're having right now is as the filter goes off the map to the left, it actually needs to be resynced to the right and then be brought back over, if that makes sense. So it moves all the way over, and then it needs to be brought back over this way and then go back over again. So that, I think, is the issue that we're having right now, and that's what we need to solve. I guess we're around out of time for stupid questions. No, please ask as many stupid questions as you want. I appreciate stupid questions as well. I'm off to bed. Have a great stream. See you, Radu. Thank you so much for coming in. Anakin, Luke, hey, how are you? I hope you're having a great day. Codename Koi, thank you so much for following. Really appreciate it. Have you ever accidentally set yourself on fire? And if so, when was the last time? I do not think I've ever set myself on fire that I'm aware of, but maybe in Boy Scouts at some point. I'd forgotten I call you Jams. Wait, what? I thought it was just a misspelling of James. Okay. So what do we have here? So we have signal 1 and then, oop, hello. And now we have signal 2. Okay. So what we need to do, so it's going to be I plus the length of signal 2. So it is I, go man. 1 second. So it's I to I plus length of signal 2. And then if signal 2 goes off the map, then we bring it back around. Okay, so I think it should be, I need to think about this. This is pretty cool. Are you doing this just to visualize a convolution, or are you planning to use it for something else? Right now we're just visualizing the convolution, but we are already using the convolution in something else. Learning about modulo indexing, yeah, because mathematically it is f of gx is equal to int. Yes, that's true. That I think that's exactly what it is. Wait, what is Frect Chemist doing? Sorry about that. Pro puke, toodles. Wait, have you? Oh, set yourself on fire. And Frect Chemist. Yeah, I'm almost positive Frect Chemist would have done something like that. Okay, guys, I've got to go get a quick. I've got to fill up on water, so I will be back in just 5 minutes, and then we'll try to get this visualization done. Sorry about that. Well, not 5 minutes. It'll be like a minute. So just give me a second. I'll be right back. Sorry about that. All right, give me just a bit. Okay, back. Give me just a second. And right, so you guys should be able to see my face now. What do we have here? Did I just... What just happened? How did that happen? Anyway, let me go ahead and catch up on chat. What do we have? Just part of regular living. Setting yourself on fire or getting water. Internal compiler error, segmentation fault. First time I've been able to break GCC that bad. Oh no. I guess if you do first, you might also do second. Gonna find a clip of that. Xpencha, thank you so much for following. Really appreciate it. As far as like segmentation faults, like I know Julia is a language that shouldn't get segmentation faults, but man, I get segmentation faults all the time. Ah. May have just dropped my headphones. Give me just a second. Perfect. Okay. Right, so my goal by the end of the stream is to have this 1D visualization done, and then we can go from there. Again, I've already been streaming for 2 hours now, so, you know, we'll see. I need to start doing longer streams and get my stream stamina up, so I'm happy to do a bit of a longer stream. Besides, I'm nowhere near being done. Like, a lot of times we just get, like somewhere, and we never get as far as I want to get on stream. So I'm happy to have more casual streams where we get a little bit more done type of thing. So, okay. I don't know about you guys, but I can never put both headphones in. Like, I don't know what the deal is, but I just get really, like, worried. Like, I don't know what... Okay. One headphone in, totally fine. Both headphones in, I become, like, really OCD and, like, really, like, nervous all of a sudden. I don't know why. I just can't have both headphones in. Anyway, let's keep going. So we have the rsum here is going to be equal to signal here. So what is the issue? The issue is we have our little... Okay, one second. Let's open up the... There we go. Perfect. Okay. So we've got our little wave here that is moving that direction, right? So she's going this way, right? And so essentially what we're doing is we are iterating through. So our convolution of filters is going to 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 blah. And what I want to do is I want to make it so if we're at a stage, let me just redraw this figure. So if we're at a stage where we're just going to redraw it, our Gaussian is here, but our filter is, for example, here, right? Then what we need to do is we need to deal with this boundary condition. And what I think I want to do is I want to make it so it grabs these elements over here. If that makes sense, right? So that's kind of what I want to do. So how do I make it periodic? I did it before, now we just have to do it again because I've completely forgotten. I need to be able to hear what's going on around me. Yeah, right? Like, I don't know. That's why I can't do like the over-ear headphones. I have to do the in-ear headphones. It bugs me. Like, it really freaks me out when, like, the thought that someone could be behind me really freaks me out, which is why I can't work very well in like an open office plan. Because like, I can't focus on anything, right? If I start focusing on work, you know, there could be someone behind me. And just the thought that there could be someone behind me really freaks me out, you know? I like open back on ears. Yeah, so I guess I could do like, yeah, the open back headphones could probably work as well. But I don't know, there's just something about the fact that someone could be behind me at all times that really, really freaks me out. And somehow putting this other headphone in gives me that like weird like feeling that someone could be behind me and like watching me work. I don't know why that freaks me out so much, because it's usually like I'm usually getting work done. It's not like I'm not doing anything, and it's not like I should be afraid of them looking at me while I'm working. But just, I don't know, I've got this weird phobia of people like looking at the back of my neck, which is why I always have like a collared shirt on anyway. And nowadays I have long hair as well, which also helps with that. But like, it's I don't know, it's not good. I get freaked out really quickly. Okay, so what's going on here? So we're gonna say signal 1. Chotomate, signal 1. Is going to be indexed such that it's going to be I 2, and right now I have it I plus, I guess I want to say I plus max, right? And so I guess what I actually want to say is, I really got to think about this. Chotomate, very primal feeling. Yeah, so, sorry, I sometimes will say Japanese things. I need to get better at Japanese, honestly. My Japanese is really bad. But one day we'll get better. I'll get better. I mean, Eventually. Sometimes people in chat will say something in Japanese, and my kanji reading is just awful. Like, I'm only able to read, like, the very most basic kanji. So, okay. So signal 1, the way it's currently indexed is the following. I'm just going to write how it is indexed now and how we want to index. I, 2, I plus length of filter 2. And we'll just say length of filter. Oh gosh, one day I'll be able to write, but that day's not today. Filter. Okay, so the idea is if the filter is 10 elements long, it's just going to be I to I plus 10. That's how we're indexing it right now to grab the elements of our array in there. But what we actually want to do, we need to deal with boundary conditions in some way. We could do this in a number of different ways. I suppose instead of making it periodic, we could just make it. So here's I guess where we should actually talk about different boundary conditions. So in principle, let's just do a basic boundary condition for now. And then I want to do periodic. I think periodic is the best way to do it. I know that's lame, but periodic is the best way to do it because we'll also talk about the convolutional theorem because we will, and the convolutional theorem is always periodic. So let's just do periodic. So this is going to go from I to I plus length of filter, except for the case where I plus length of filter is greater than, yeah, let's just figure it out. So we have to figure out the indexing. Why do I still have voiced up? Okay, so we have to figure out the indexing. So here we're going to say if I plus length of filter, can we just create a range? Let me just mess around with Julia a bit and see if we can create a range. So let's go here and let's just say range. And can we just do 1 to 10 and then also add in another range, which will be from like 10 to 15, well, 6 to 7 or something? I don't know, it doesn't matter. No, that doesn't work. But how do we... Oh, we can give it a subset of arrays to index over. Of course we can. So if we do A, it's going to be equal to, let's just say, I for I equals 1 to 100 or something like that. This will give us an array, and then I can just do A of 1, 2, 3, 4, and that should give us 1, 2, 3, 4. Oh, great. Okay, so that's what we want. So then if we do 1, 2, 4, and then we do 5 to 6, that doesn't work. Okay, so that doesn't work. How do I give it 2 separate ranges to work over? Can I do that is the question. And I don't know if I can. But we do know how many elements over we are at any point in time. So we can find this, right? How many elements over we are. Because hello, chotomate. Because this is just going to be the I plus length, 1 second, a filter, length filter minus, I guess I'll bring the minus down to the next line, minus length of signal. Okay, I just can't type. So yeah, that wasn't even typing, I can't write. Not sure how I got here, but this looks fancy. PogChamp, oh, thanks for that. Reviolin, thank you so much for following. Or is it Raviolin or Raviolin? Like, are you more of a pasta type of guy or like an instrument type of guy? Anyway, thanks for the follow. Really appreciate it. Okay, so that's going to be how far over we are. So that's going to be how many elements we are over. So then in principle, we could index from the following. Raviola is equal plus violin. Simple for right. So the question was, how do you pronounce it? Is it Raviolin? Is that, it doesn't matter. Anyway, thanks for following. Really appreciate it. Hope you're having a wonderful day. So I guess what we actually want then is from 1 to, 1 second. 1 to this value over here, right? So that's how far over we're going to be. 1 to that value. And then we're also going to grab from, I've got to think. Doesn't matter how you pronounce it. That's fair. So 1 to value, and then we also need this indexing in here. So we need these 2 sets of indices. And we probably want to vertically concatenate those guys together. So Um, no. Dang, why am I overcomplicating this? Well, never mind. This is a Simuleo stream. Of course we're overcomplicating things. That's just the nature of the stream. Okay, so 1 to value should be fine. Whatever this value is, I'm just going to call this value val. And then we're also going to concatenate this guy up here. So, sure, that's fine. And then what we have to do is we have to say the filter is going to be from value to end. 1 second. And then should be from like concatenated with 1 to value or something. I'm just making this up, but this should be what we need, I think. So what I'm probably going to do then is I'm probably going to go up here and I'm going to say if the I plus length of signal 2 is less than let's just do very stupid boundary conditions for now, and then we'll also implement other boundary conditions as well, because obviously we need more than one boundary condition anyway. So let's do stupid boundary conditions. We're going to come back to the indexing later. So if this is less than or equal to is also fine. Length of signal 1, we do the following, and then we do signal plot, and we have an else statement in here. We're just going to end here. And we're just going to say, otherwise, the residual sum is going to be equal to 0. That is the simplest boundary conditions possible. If we're off the map, everything's equal to 0. That's what we're going to do. I'm not going to worry about it. Okay. After all that discussion about indexing, I'm just like, let's just not deal with it for now, you know? Okay, so let's do the last include statement, which should be this one. And then we run the last main, which should be that one. And that's going to fail. Perfect. Wonderful. Does programming exist? That is a good, deep philosophical question that I should totally go on a ramble session about, because I don't know what I'm doing. Gomen. Let's keep going. I just noticed 46 stars on the algorithm archive since 21.11. Is that good? I don't really know. Does math exist? It does, in a sense that it exists. Okay, so where does this break? It says closest candidate, no method for time star length of complex array. What is your issue? This is obviously going to be on line 66, which should be this line here. Oh, if I plus length of signal 2. Try that one again. All right, it is running. We're getting something, and it shouldn't break at 100. Perfect. Okay, so, and just to go up, we are definitely having values that are significant. Perfect. Okay, so let's go ahead and take a look at the visualization here. But we're never setting the output value. Perfect. Okay, that's exactly what I needed. Okay, so now if we just grab this guy, yank, and move this up here, paste. It should, in principle, do what we want. So let's include main, give it a second, see what happens. What's the worst that could happen? And now we're just going to run Mirage. Take a look what we got here. It's going to move over, and we should see. Boom, look at that. Yeah. It's not that exciting. But hey, we got it working. So here we have our triangle wave going over. You see the green being the two of them multiplied together. And then we see the purple down there being the convolution of the two. Wonderful. Okay, so the next thing I want to do is try a sawtooth. Instead of a triangle that goes up and down, sawtooth only goes up, and see what we got. There were 16 stars in January 2020. Finally compiled. Have a good stream. See ya, Earmitten. Can have a wonderful evening. And yeah, hopefully I'll see you around. Tux Dude, thank you so much for following. Really appreciate it. There were 16 stars in January 2020. Look, I'm going to be honest. We really need to ramp up the algorithm archive work. But how is... Oh, I know why there were only 16 stars in January 2020. I had not published a video the entirety of 2019. Therefore, there was no PR for the algorithm archive. That's one thing that I realized. Like, the project is vitally dependent on me, providing PR for it. And so like, I know that my job, I have so many things I need to do with the algorithm archive, but also like, it is vitally dependent on the YouTube channel and the Twitch stream to some extent and all that kind of stuff. So we have more stars in 3 days than in 3 months of 2020. Sorry. Programming, even at the highest level, is ultimately nothing more than layers and layers of abstraction over symbol manipulation. Can you feel a symbol? Isn't there a song like "Can You Feel the Sunshine"? That's a song, isn't it? 1 second. Can you feel the sunshine? Isn't that like Tails Doll? Yeah, can you feel the sunshine? Yeah. Okay, hear me out here. Hear me out. Just hear me out here. Hear me out here. There's a song, Can You Feel the Sunshine, from Sonic R. Feel free to Google it if you want to hear it. It's a stupid song. But there is this thing, it's called the Tails Doll, and this is the theme song to the Tails Doll. It is essentially Tails Miles per Hour, which is that two-tailed fox in Sonic, with a little bob in its head, and it's like this weird, like, voodoo doll version of Tails, right? And that was the alternate costume essentially for Tails in this game. And there's this thing called the Tails Doll Curse, which essentially is if you unlock Tails Doll in Sonic R, it is cursed, and it will like turn on your Dreamcast or whatever it was, whatever the console was that it came out on, and it will cause you to like kill everyone in your family or something like that. It's like super dark. And when I was a kid, I didn't have a Dreamcast, but I did have a GameCube where it had like all the collections of Sonic on it, and one of it was Sonic R, and I was really hyper-focused on Tails, and I was super happy to get the Tails doll because I was really excited about like this kind of like, you know, a macabre version of Tails. I thought it was really cool. But I started looking up how to get Tails doll. I found the Tails doll curse, and I was terrified, like absolutely terrified of the Tails doll. And at some point, like our TV started going on the fritz, and it would just start turning on at random. And for some reason, this happened around the same time that I got Tails doll and Sonic R. And I was like, oh crap, Tails doll is coming out of the TV, and it's gonna kill me. And I was terrified of this for weeks. Like I didn't sleep because of it. So I don't know, like I don't know why that came up. I think it was because someone asked if you can feel symbols, and if sunshine is a symbol. I get that. Like completely unrelated rant. Just wanted to say something that terrified me as a child that like really shouldn't have terrified me. And yeah, it was creepypasta, definitely. How did you prevent Tails doll from killing you? Oh man, it was tough. The trick was to actually think out things logically, which is really difficult for me. Like okay, so let me make sure this convolution works with the other signal. So we're gonna do y is equal to that, and just make sure it produces the correct visualization. So we're gonna do include. Now we do main. Give it a second. Fairly certain it did not work for that. Let's take a look at the image. Okay, the visualization is correct, but the convolution is definitely wrong, and the r-sum values are also wrong. And this is because I know exactly why. Okay, I got it. I understand. Okay. If we're doing the convolution in this way, and we have two very big signals, yeah, we're always going to be in the case where I plus length of signal 2 is going to be less than or equal to the length of signal 1, because the length of signal 1 and the length of signal 2 are the same. So in that case, we definitely do have to do the periodic indexing, which is great. Let's go ahead and do that now. Yellow Nor, thank you so much for following. Really appreciate it. Okay, I'm really hyper-focused on getting this visualization out, though. Like, I think we can do it. It's just a matter of just, you know, doing it correctly. I was going to say do it to it, which is a Goofy movie reference, and you guys are like totally understanding my childhood at this point if I'm making so many bad references to things that no one cares about. Okay. I don't know how much longer we're going to be streaming. I'm definitely going to do everything I can to get this visualization out by the end of stream today. I've already been streaming for 2 hours, and usually I only stream for 2 hours. That's just my usual limit. But I will probably, I'm trying to do longer streams, so we'll try to do 3 or 4 hours today. We'll see. Hey Janssen, how are you? But which Goofy movie? Isn't Do It To It like the extremely Goofy movie, like the second one? I watched more of the extremely Goofy movie than I did of the original Goofy movie, and I know that's sacrilege because most people like Goofy movie more than extremely Goofy movie. I get that, but it is what it is. Okay, So now we've got to do the indexing here, which is great. So we know that one version works. In fact, let's just go back for a second and let's try a sawtooth, just so that we're not going too far off here. So we're going to do 1, 2, let's just do 3, 4.0, and then 5.0, okay? And let's normalize Y down here. Oop. G. Let's normalize Y as well down here. And let's just make sure the sawtooth works as expected. So we're going to do include main. Give it a second to make the visualization. And then we're going to do the mirage here. Okay, so we see the sawtooth is coming through. We should see, yep, it should be a Gaussian that's slightly shifted, I believe. It is slightly shifted. Perfect. Okay, so this convolution seems to work. Now the question is that shifted in the right direction? I think it's not. I think it's shifted in the wrong direction. I think it needs to shift the other direction. But that's okay. That's something to figure out later. We'll get there one step at a time. Would you consider yourself a polymath? What's a polymath? Person of wide range knowledge or learning. No, I mean, I would like to, if I could, consider myself to be a polymath, but I didn't even know what that word meant. So therefore, I really don't think I could consider myself to be a polymath. It's one of those things that, like, I wish I knew a lot about a bunch of different things, but honestly, most of my knowledge is focused on, like, you know, one particular subfield that is computation. You know, you could argue I know a lot of math and I know a lot of physics, and I am definitely multidisciplinary between the two. You know, physics, computer science, this type of thing. But honestly, I don't know what qualifies a person for a polymath, right? Let me see. An individual whose knowledge spans a substantial number of subjects, known to draw on complex bodies of knowledge to solve specific problems. I don't know. I'd like to, but I don't know. Not even Terrence Tao is a polymath, so I don't know who Terrence Tao is. So I am. Who's Terrence Tao? Oh my gosh, why do I know so little? He holds. Okay. Yeah, I don't know who this is. What was he known for? That's because he's just a mathematician. What is he known for? I'm sorry. Like, the thing about mathematicians is, like, what distros this is Arch Linux, of course, you know? There's only one true distribution, which is Arch Linux, so that's what we're using. Okay. Super smart kid. Cool. Good for him. How old is he? 1975. He's not a kid. He's age 45. That's very far from being a kid. Young. Okay. 45 is hardly. That's like 1.5 times my age. If AFAIK. What does that stand for? As far as I know, Terrence Tao is considered to be the greatest mathematician of the time and one of the greatest of all time. Really? Oh, interesting. PhD at 20? What do you mean? But did you get PhD at 20? I did not. He's probably the best mathematician alive today. But people don't say young forever. That's true. I mean, like, the question is, what counts as... Okay. I mean, I'm not going to get onto this. Like, I really am not. Doesn't he have the highest IQ? Okay, there's just so many, like, weird pseudo-intellectual things happening in chat right now that I'm kind of like, I don't know if I agree with any of this. But fine. Like, I'm actually, I don't think I really want to... There's not really much to say here. It's just that I don't think IQ is a good measure. I don't think people should rely on IQ as an actual measurement of intelligence. That's what I will say about that. As far as Terrence Tao being the best or smartest mathematician, could be true. I don't really know the field so well, and that I feel like it could almost certainly be true. And probably I should know more about math, but I don't. So, I mean, I'm having trouble just implementing a convolution. So clearly, I'm not particularly up there, you know? He got field medal at 31. Yeah, so I need to learn more about math, is what you're telling me. I'm sorry. The problem is, like, this is the perfect channel. Like, I should know about this, but I just don't, because I don't follow people, really. Like, I follow ideas, you know? So, like, yeah, I knew that sounds like so, like, I just don't know people, right? Like, I know Einstein, and I know, like, old guys, like Gauss and stuff, but, like, I don't know, like, any real living person, really. So, multidisciplinary is what I consider polymath nowadays. Yeah, I mean, talking about polymaths and stuff like that, it is different, right? Like, I don't really know. I don't know what's considered polymath and what's not. Seeing true multidisciplinary work is incredible. I feel like that was what OIST was supposed to be, and it did a good job at some of this, but it ended up just being a bunch of disciplines put together instead of truly multidisciplinary. Alternate Terry Tao is a chill dude who's done some cool math. Yeah, I mean, that's fair as well. I like your name. Define null 0, because null is 0. Okay, so let's deal with these periodic boundary conditions, shall we? Let's just do it. Okay. Also, I do think we're iterating through incorrectly. Let's iterate through the other direction then. So we are going to do for n minus 1, n minus 1 to minus 1 to 1. Okay, let's just do include main, and let's see what this does. I'm not sure there's a true polymath since Leibniz. Yeah, that's the thing as well. It was easier to be able to... Oh no. That wasn't what I wanted to see. Crap. Okay, you're right. I'm wrong. I'm dumb. Okay, let's try this again. It should be 1. I was iterating through the wrong guy. N minus 1. The filter is the thing that needs to be flipped. It should be right. It's not the way it goes around. We just need to flip the filter. I did that wrong. What should they rely on if not IQ? What are you using for plotting, by the way? I'm actually just using plots.jl, and I'm just combining it all into a video at the end. And I agree with that. Achievements and discoveries, I think, is the best way to do it. But also, like, why is everyone so caught up in this idea? Like, why are we ranking ourselves against other people to begin with? Like, why? Like, I think this idea that, like, one person is more intelligent than another will come out in conversation, right? Like, if you talk to someone and you genuinely try to understand their ideas and the way in which they think, totally fine. Like, and you can probably at that point make a claim about people being intelligent or not being intelligent. I think that's totally fine. But and for psychological research, probably there is a utility in having some sort of value like IQ. But for me and you and people who are not doing psychological research, I feel like this idea of IQ, this idea that we're ranking ourselves based on intelligence, like, and we're just saying that these guys are godly intelligent, these other guys are not intelligent. I feel like I think it's just bad for your psyche. I think it just makes you feel inept. And I don't think we should be, encouraging behavior that puts some people on a pedestal just because they tend to do well on certain tests, for example. Does it? I guess I'm trying to be. I'm kind of skirting around the big issue here, which is that we tend to idolize a lot of people who are intelligent, and that idolization, I think, is the downfall of a lot of like science communication and science supporting people. But let's see. Let's see. What should they rely on if not IQ, achievement discoveries? But as Simulator sort of points out, all these young genius things happened a while ago. Yeah, so it's much easier to be like cross fields when the fields are smaller. Anything else? Let's see. Ask a psychologist, or preferably nothing at all, to establish dominance, I guess. But yeah, like, why do you need dominance? Like, it's not like, oh, I'm smarter than you, therefore. Like, the average person could also be the most successful person. IQ seems irrelevant. Right. Because ranking and awarding these top ranks is the most common strategy for how to distribute resources in academia. Well, okay, but okay, you're right. People do a lot of ranking here, and that shouldn't happen. You're correct about that. Who says I'm not a psychiatrist? That could be true. I mean, if you're a psychiatrist, hey, I need help. Just because you have high IQ doesn't mean you have your life under control. Everybody is not made the same. We have to acknowledge that. That's true. Everybody's not made the same, but also, like, the differences are not that major. I feel like, and of course, maybe I'm very naive here in saying this, but I feel like, the concept of nature versus nurture, I feel like most of your intelligence, and again, this is a big feeling, a gut feeling as someone who's never studied the topic, but I just feel like most of your intelligence comes from nurture over nature. You can, if you take the time as a child to learn proper studying habits and really enjoy the process of learning, I feel like at some point you'll be smart enough to do whatever the heck you want to do, Anyway, that's, maybe I'm ranting again. I should probably stop doing the ranting here. especially if you have ADHD or autism, is very subjective. Who people consider intelligent, method, naive. And as far as psychology goes, I believe that field has moved on from IQ tests a while ago. Well, not in France, apparently. We're so late in the psychology field. The other thing about psychology research, and again, I don't mean to... I'm not saying psychology research is bad. Just to be clear, that is not what I'm saying. What I'm saying is it is a very difficult field to get accurate results in. And it's just... because you have to deal with people, and people will always just... They're hard. They're big biological organisms with so many working mechanisms. It's just... It's difficult to say that, like, I don't know. I feel it's very difficult to properly analyze someone's intelligence, and I don't think that psychology can appropriately do that. Statistics is like psychology, hard to get right. Yeah, I mean, psychology is mostly statistics. That sounds like behaviorism, but the premise that everybody can learn the same given the same input only applies to computers. That's potentially true, but also I don't feel it's so far off. Okay, maybe you're right. Maybe this is stuff that I don't know about. Maybe I'm just talking, about stuff I don't know. I mean, I did psychology research a long, long time ago, back in undergraduate. But again, never as a graduate student, I never really studied it that in depth. So the question of behaviorism and stuff like that, I don't really know. But what I do know is that I feel like. And again, this is from a very biased perspective of someone who never really struggled that much in school, right? Like, I never really had trouble with it, and everything kind of came to me easily. And so because of that, I guess I can say that I feel like everyone can learn anything because everything's easy to some extent. It's just a matter of time. You just have to put a certain amount of time into something to understand it. It's not a matter of something being difficult. It's a matter of you putting enough time in to understand that thing. You can get pretty far if you get used to really applying yourself. I want to take back my statement. Intelligence tests are still used. That's cool. Thanks for... I didn't know that. Thanks for letting us know. Anyway, we're now having a huge discussion about this. I'm not really sure what psychology is doing, to be honest. Okay, I feel like the problem with this is we're going to just go down a rabbit hole and talk more and more about, like, stuff that doesn't really matter here for the most part. So maybe we, hold that for now. Like, you know what I mean? Ranting and looking at graphs is fun. Best IQ test is having someone implement a compiler. Well, that only works if people know what a compiler is, It's becoming quite convoluted. Oh, non-dairy neutrino, you and your puns. I simply had a thought and went, that seems right. I'm sorry. To be fair, like, I was having this discussion with one of my friends the other day. Like, there are a lot of things that I assume are true. I will say that I assume X is true. And when I do that, I usually try to, also provide caveats for that discussion. I don't say X is true. I say, I believe it's true for these reasons, or like, I think this is true for this reason, or something like that, Like, and I guess what Amber says is what I was trying to say as well. Like, everyone's going to say something that they think is correct, but the thing is, you thought it was correct, and then you went to double check. Therefore, even if you did mislead the conversation, you fixed it, and that's good on you, is what I'm trying to say. Are you still in that apartment in the ghetto? No, not anymore. I'm now in a different ghetto. But luckily, I'm no longer paying for that apartment. And, man, oh gosh, when I went back to that apartment, there were six dead mice in that apartment. 6 of them. It was insane. I mean, the roaches were gone, at least. But man, like, that apartment was the worst. My roommate was, my downstairs neighbor was stealing my mail. Oh, it was awful. It was awful. Like, I could not believe how just, like, awful it was. I hate living in cities in the US. It's just awful. You're still at MIT. I actually will be leaving MIT in 2 days. So my last day of work is January 5th. And then I'm just doing my own thing for a bit before starting a new job. So, again, the truth is, I feel like if I would have done MIT under different circumstances, it would have been a lot better. They weren't enough. They weren't enough. Did your neighbors want to pay your bills? Actually, funny story. Pretty sure my neighbor was using my electricity. Because when I left to live with my parents for a few months, because of course I did. I wasn't going to be living in that apartment for forever. I still had to pay for it, and I still got electricity bills. And my electricity bill spiked when I wasn't even there. So pretty sure pretty sure it was like my apartment was also using my electricity for a bit. You're not even be able to have subsidized housing with a flat like that. Drift towards another rabbit hole. Yeah, okay, we need to stop. We need to get out of the rabbit holes. Hey, Uncle Bill, how are you? It's been ages since I've seen you on stream. I feel like maybe I just saw you the other day and I just wasn't paying attention. How are you doing? Oh, man. Oh, come on. What am I doing with my life? The answer is nothing. Stealing electricity. Man, oh man, that apartment was just bad. Like, I don't understand how I had gotten such an awful apartment. Like, again, this is why I say if I had not moved into, like, if it was in Boston, Somerville in particular. I can say that since I don't live there anymore. I like rabbit holes. Are apartments in Japan better quality for a given price? I think so. I mean, at least the one in Okinawa, I paid like a third. Okay, actually, I paid a tenth because OIST subsidized the housing. But I paid 10 times less for an apartment that was, way, way better. Just so much better. It was amazing, honestly. Which is why when I kind of got duped when I came to the US, I wasn't used to looking for, like, ways in which the landlord would try to steal money from me. I was more like, let's go and let's just, like, I'm sure it'll be great because it's an apartment and I'm sure they did their due diligence to make this apartment as good as possible, Like, I came in so optimistic because I just assumed that the apartments would be great. But because I was used to the one from Okinawa, it was a pain. The rabbit hole trails and lounging in the rabbit field. Anyway, what I'm trying to say is if I would have done, like, started MIT, not with COVID, and in a better apartment, and, if I wouldn't have had to live with my parents for 6 months, and, if the job wasn't so stressful, and if we didn't need another developer and all this kind of stuff, if all of these ifs were true, I probably still would be working at MIT, so but none of, like, there were just so many conditions, and I just said, you know what, let's just take a break from academia for a year, and that's what I'm doing this year. That's what capitalism will do for you. Just be rich, no rat-infested apartment. But that's the thing, like, I think I'm relatively well off. Like, I'm not rich by any stretch of the imagination, but the amount that I was being paid at MIT was over average, right? And so buying an apartment, for renting an apartment should have been relatively good. I should have been better than 50% of the people living in Boston. Because I had better than 50% of the revenue of people in Boston, like over average. So you'd expect it to be better, but it wasn't. It was well, okay, maybe it was, but still, like, man, is this Lua? Maybe someone from chat can help. No, this is Julia. But then I never actually finished anything either. Taxes are super low in the U.S., right? I mean, I paid 40% of my income. I don't know if that's low or high. So. Anyway, so what we have to do now is we have to deal with the cyclical nature of this guy. So, I think it's 40%. Well, I can do the calculation, but I'm not going to do the calculation because then you guys know my salary or what my salary was before I left MIT. Okay. So we first have to find the value, which is going to be I plus length of filter. So let's actually do end val is what I'm going to call it. It's not a good name, but it's just going to be equal to this guy. Oh, we have to iterate through. So dd and paste up here. And we're just going to say that. I plus length of signal. Actually, that's not what I need. Okay. Let's go down here, and we're going to say offset is going to be equal to I plus length of signal 2. Okay. I plus length of signal 2. So if I plus length of signal 2 is less than, so now we're going to do minus length of signal 1. Okay? And so now what we need to do is, you pay 30% in Sweden. That's pretty good, considering it's Sweden. I feel like I need to calculate this really quick. I paid... Wait, let me do the calculation one more time in my head. You're right, it wasn't 40%. You guys are right, I'm sorry. It was closer to 30%. Maybe even less than that. But it depends on the tax bracket. Let's see. I must have gotten in some nice with that. Um, man, I'm not even gonna go into government spending here. I really shouldn't go into government spending. Because like everyone thinks the government is spending money wrong, and I'm like, just don't spend any money on the military. Put it all into like education. That's what I want, and they don't ever do that. Like it's the opposite of what I want. Um, Considering Sweden, um, let's see. If you speak about taxes and don't even think about Italy, I pay 138 euro per year for housing taxes, zero income tax plus sales tax. So that's probably 100 or more euro, 100 or so euros per year. Huh. That's pretty good. RoboThink, thank you so much for following. Really appreciate it. Tax brackets when income reaches average and above average, it jacks up fast. Well, there are many different types of taxes. I did not think that I would fall in love with a programming language by reading 2 sentences description. I'm glad you like it. So it's really complicated. Something odd, military spending includes research funds into academia. Some of it does. But here's the thing. The funds that go to academia usually come from Department of Justice, DOJ, and that funding has way more holes in it, or way more like, not loopholes, but like catches associated with it than the funding that comes from the Department of Energy. So you kind of want more to go from go to the Department of Energy to do a straight comparison. Something on military. Wait, it's just really complicated to do a straight comparison, right? Well, is that marginal tax rate or overall rate? Anyway, I'm sorry. The statistic I gave you guys was wrong. It's not 40%. It's closer to like 20 or 30%. I do apologize for that. I like doing the math in my head was just bad. I had my take-home salary at the end of the day that I could use on rent was 60%. But that's, I also had to pay for healthcare and stuff like that. So there were additional things that I also had to pay for that I had kind of lumped together into sums that I have to pay. Okay, so the offset here is going to be that. So now we're going to say, we have to do the sum here. So we're going to say our sum is going to be equal to the sum. And then we just have to figure out what signal 1 times signal 2 is. So it should be the vertical concatenation of, and this is where we're going to kind of mess around with some indexing here. Signal 1. And then we do some indexing, and then we should do another signal 1. Here, okay? And now we're going to do dot times, and I'm just going to move the dot times down to the next line, because I think that's the way I should do it. Dot times, and then we're also going to have to do a vertical concatenation there. VCAT of signal 1, signal 2, and then we have to figure out the indexing here, and then signal 2, and that should do it. Now the indexing for signal 2 should be straightforward, because it should be the offset, offset to end, to end, and then the other one should be 1 to offset. So that should be those indexing. It should be fine. Is this some Julia code? It is indeed some Julia code. Jeffrey Hinton, father of AI, went to Canada to get non-military funding for his research. Yeah, I could imagine doing that. This is Julia code without any syntax highlighting. You're right, I could use syntax highlighting, but I don't, just because I don't use syntax highlighting, and you guys can deal with it. Okay, let's just keep going. So I think these are the right indices here. I think we're off by 1 somewhere. So I think what we're going to do is we're going to say, let's see. So if I plus signal 2, so let's say signal 2 is 10, that means it's going to be like 110 at the largest, is less than length of signal. So that means it's greater than. So if I plus signal 2, okay, so that means I is going to be iterating through. I is going to go from 1 to 100. If the array is 1 to 100, that's fine. So then when I is equal to 100, what we want to do is we want to grab only I. And how do we know we need to grab only I? That is because it should just go from I to I. So that means that, I really need to think about this. I'm sorry, my indexing sucks. Array indexing starts at 1. Yeah, that's actually a big problem I have. I'm not sure we can deal with no stitching styling, but it'll never be. Oh, I disagree with that, but hey, whatever, it is what it is. Okay, so signal 2, the offset is how many elements over we are. And the number of elements over that we are is going to be I plus signal 2 minus signal 1. So if I is equal to 100 and our signal 2 is equal to 10, then this is going to be equal to 10. And so it should go offset to end, which is going to be 10, and then 1 to offset minus 1 is what we want. I had to figure out where the minus 1 went. Okay, so now for signal 1, this is going to go, and we have the indexing here. I to I plus length of filter, and it should just go... Oh, we also need to flip these around. Yeah, we need to flip these around. This should go 1 to offset minus 1. And then this should go from offset to end. Okay, then up here we're going to do... I got to think really quick. This is going to go from 1 to... I think it's still going to be offset minus 1. I believe. Yeah. I think it's still going to be offset minus 1. I think that's fine. And then it's going to go I plus length of filter. And then I to I plus length of signal 2. Oh no, minus 1. Oh, there's minus 1 up there. Oh crap. Why is there a minus 1 up there? So I guess then, in this case, this has to have the minus 1. How does that make any sense? I guess it's just this. And then I believe the minus 1, the length of signal 2, let's just remove the minus 1 there and see what happens. So we're going to include this guy, and we're going to run main. We're going to see where it breaks. Perfect. Breaks at the start. Pengo Ray, thank you so much for following. Really appreciate it. Array-indexing is one of those the two main problems I have with Julia. The second is column first. Well, that's just Fortran like indexing. Yeah, so to be fair, I don't mind the column-based indexing. I think that's actually fine. But the off by 1 or the 1-based indexing does really confuse me because I always think in a 0-based way. And so the Julia 1-based indexing just kind of throws me for a loop every time, specifically when I have to like do GPU computation, and a lot of times I'm going to have to do like n-dimensional array axes, but I have to pretend like it's a 1-dimensional array, so I have to flatten it and all this kind of stuff, and then the off by 1 gets me every time because I always forget to subtract 1, and then it takes like 30 minutes to figure out. It's a pain. Like, I get confused really quickly. Okay, so does this make sense? So length of signal 2, I plus length of signal 2 minus 1. So where is this breaking? It is breaking at line 67, which is this line in here. And the reason it is breaking is because we do need a minus 1 in there, I guess. Yep, we probably do. Okay, so minus 1, let's add the minus 1 in there. And let's see what happens if we run it now. Whoa, it's actually running. And it broke. Attempt to access 100 element array at index 96 to 101. Okay, so that means we're probably in this else statement in here. So what I'm going to do for now is I'm going to yank this line, paste it. I'm going to comment this out, and we're going to iterate backwards just so that we can hit the error faster. So n minus 1, minus 1, 1. So let's try running that again. Include main. It should break immediately. Perfect. So let's try to figure that out. And we should be in this else statement. Print line. I don't know. Yo, yo. Yo, yo, yo. Wonderful print line debugging. You guys just have to deal with it. We are in the error. We're in the statement. Perfect. Okay. So let's just print line the offset then. And see what we got. Offset is offset. Okay, we're going to do include main. It should be offset is 4. Perfect. What do we have here? You'll ever notice that the magnitude of a complex number is also the real part of the analogous vector and the complex plane rotated to the real plane. Maybe it's yeah, that's how it works. But I just thought it was interesting to think of norm as a rotation. Yeah, so there's a lot of these weird like visualizations. That's one that I've come across as well. That just come up, and like understanding complex numbers is one of those things that I really wish people did better in high school. Like you learn about complex numbers in high school, right? But like it's really hard to like grasp what they mean, you know? Complex number can be represented as magnitude and phase, right? So that's typically how I think of it as well nowadays, but it took me a while to get to that intuition. So okay, so it is 4, that is what we expect. So then attempt to access a 100 element array. So this is going to 1 to offset. So this goes to 1 to 3. Perfect. And this goes from I to I plus length of signal 2. That's where it's wrong. This needs to go I to end. Yeah, okay. So now we're going to do include main. Doing stuff. Great. Okay, so now if we do mirage out. Okay, backwards, but I think it's almost there. Okay, so now the question is that... Oh yeah, we still have to flip the signal. That's fine. We still have to flip the signal, but that's totally okay. So let's do the big Gaussians. Make sure that works as anticipated. So we're going to comment that out, and we're going to comment that out there, like this, and we're going to try it again. So we're going to run include main. Okay, got a bunch of offsets. All of our z-sums are 0 though. Our sums, they're all 0. So we didn't get what we expected there. So if we take a look at this, yeah, it didn't work. Perfect. Mr. Tibbs, thank you so much for following. Really appreciate it. I did a bit of electrical theory in my first years of higher education, and complex numbers are used pretty much everywhere. Right, yeah, definitely. That's the thing. Like, a lot of people, specifically when they do electrical engineering degrees, like, their entire degree is just living in a different space. You know, like, okay. Plobpeg, thank you so much for following. Really appreciate it. Okay, so if the residual sum is equal to the sum of these two guys multiplied together, and it's going to be 1 to offset minus 1, and then signal from I to end. I to end. Is that correct? I think it should be. Okay, so I got to think about this. So we don't have any... So the offset is related to I. It was on Teo's stream that he talked about defining the negative reals as positive reals rotated through the complex pi. Another way of defining something via geometry. Yeah, so there was a really good series online. It was called Imaginary Numbers Are Real by Welch Labs. So imaginary numbers are real. Super good. I definitely recommend checking it out. Yeah, I'll just paste this in here for anyone who's interested. Okay, what are we doing wrong? That's a good question. So the offset here is going to be... Well, okay, let's just check to see what's going on here. So let's just scroll up. Let's just run main again, because at this point it's too difficult to scroll all the way up. Main. Let's go. Okay, so the offsets seem to be correct, but let's just take a look at what we have here. So the offset is 1. Okay, so here we have the offset is 99, and then the I is 99 in this case. Okay, I don't actually know what we're doing here. So here we have two signals that are of length 100, and we're moving one signal across the other with the playlist. Oh, thanks for that, Amaris. Okay, so... we are doing a multiplication, and we're saying the offset is going to be I plus length of signal 2 minus length of signal 1. So here the offset is 99. And so the idea is that we're taking the vertical concatenation from signal 1 to 98, and then 99 to 100. That should be fine. And then we're concatenating it with the other signal, which is going to be 1 to... It's going to be 1 to 98, and then 90... Oh, and then 2 to 100. How does that even work? So if it starts at 1, aren't they 99 in length? No, they're 100 in length because it includes 100. That's another thing that gets me every time I try to think about one-base indexing. I don't know if it like sometimes I just have to do a for loop that just goes from 1 to 10 and just see what it outputs, just to see what it includes and what it doesn't include. So it also includes the last element as well. So yeah. Okay, so in this case, shouldn't it be... Let's see, so times the vertical concatenation, signal 2 is going to be offset to the end. Signal 2 is going to be the offset to the end. So the offset in this case is going to be 2. So it goes 1 to offset minus 1. So it goes 1 to 98. And then it concatenates signal 2, which is going to be the offset, which is going to be, again, 99. Oh, no, that's totally fine. Yeah, that's totally fine. Great. Okay, that's cool. Okay. So each I, we change the offset. So if I plus length of signal 2, I'm doing something dumb here and I don't know what it is that I'm doing. Should I not be changing? Wait a minute, what am I doing? So here we're saying signal 1. So the elements on signal 1 that we're multiplying by signal 2 change. But signal 2 should always just remain signal 2, shouldn't it? Let me just try changing this to signal 2, because I think that's actually what I need to do. DT, this. Try that. Include main. No, that did nothing. That was okay. That didn't work. Like I have a BS in math and took 400 to 500 level courses in complex analysis, but I'm still finding these fundamental representations and thinking I feel like I should have known that. Dude, that, yeah, 100% with you on that one. Yeah, like definitely there. There's a lot of these times when people do like complex visualizations, and I'm like, you know, I look at it, it's like, was it always as obvious? Am I just an idiot? You know, like this type of thing. It happens all the time. It's really cool that people keep coming up with new ways to do it. So, right, so it's going to be 1 to offset minus 1 times 6. I feel like this should be right, but it's not for some reason, and I don't exactly know why. So for multiplying by signal 2, let's see, signal 1. So that means we are, yeah, so we're always going to be going through and finding new elements. So it's going to start by going from 1 to 1, concatenated with, wait a minute, 1 to 1 concatenated with 1 to 100. And the next one's going to be going from 1 to 2, concatenated with 2 to 100. The next one's going to be going from 1 to 3. Oh, is that why? I have these backwards. This should be signal 1 end. Here. And then it should be that one. And now we should delete this one. Include. Main. No, it's still wrong. Crap. Okay, what am I doing wrong then? Okay, so first of all, we know this if statement works. It's just the boundary conditions that don't work. So we're getting there kind of slowly, one step at a time. I've heard visual complex analysis by Needham is really good for this kind of stuff. He's also releasing visual differential geometry. Cool. I did a BSc in math, and I never had complex analysis course until master's, which promptly dropped because I understood nothing. It's tough. So I'm 100% with you guys. It's not straightforward at all. Okay, let me get some water. We're going to figure this out. Okay. So first of all, let's just redraw everything, start from scratch, new page before. What are we doing? We are drawing a graph. Okay, and on this graph, we're going to have Gaussian. Whoa, look at this wonderful Gaussian. Okay, now we're going to have another Gaussian, which is going to start all the way over here on this side, and it's going to move its way in. So I'm just going to draw the Gaussian here. Okay, so there's that Gaussian, and it comes back around here. Something like this. So here's our Gaussian. It's a dumb looking Gaussian because I'm bad at drawing, but that's the idea. So this guy's just moving over. It's just sliding across. Well, this signal stays the same. So the two ways in which we can do that is we can keep signal 1 the same and move the filter. But because the filter is usually of a smaller size, what we're actually doing is we're figuring out which indices over this big guy here, the signal, that we have to multiply over, right? So in this way, we keep the signal the same. Well, rather, we keep the filter the same. We just multiply by the filter. Okay, so that's kind of the idea here. So let's just say this is where it is. So that means we have to cut our Gaussian like this, right? Should we go from left to right for convolution? It should. You're right. So this is actually going the other way. Okay. So this is going to be this is what I called the offset. This is what I called it. I probably shouldn't have called it that. I probably should have called it like bound or something, but it doesn't really matter. So that's kind of where, like, we're just going to say that's where we need to split up. So this is going to go from So what I'm looking to do is I'm looking to grab this guy here, which is from 1 to offset, and paste it over on this side. So it'll go from offset to end, and then 1 to offset. Is that what we have in code? That is what we have in code, from I to end, and then from 1 to offset. Now the question is, why is that not I? I feel like that should be I. So offset, do we need offset? Oh, we're doing this weird though. Like, because usually you move the filter over. So you're gonna say signal is gonna be this guy times signal 2, where signal 2 is your filter. That's fine. So here what we're saying is the vertical concatenation. Okay, so it has to be an offset because there's the potential that that the filter is smaller. That's what we're doing. Your MP4 loop is showing what you're explaining. Yeah, it's exactly, it's showing the same thing. That's what it's showing. But what I'm trying to do is figure out the indexing here to do it again. So we had the indexing working before, but quite frankly, I couldn't explain how that one worked. So now we're just doing it again. So we're kind of like redoing the visualization so that we can get it to work with variable sized filters is kind of what we're trying to do. Okay, so why then does this code not work? We're doing the vertical cat. Oh, are you kidding me? Are you freaking kidding me? Just don't even, just, oh my gosh. If this works, I'm gonna test. Oh my gosh, I can't believe it. Oh man. Well, let's just take a look at that, shall we? Right. Yeah, okay. Perfect. So let me just put in this other for loop over here. Yeah, I may or may not have redefined the sum as 0 at the end of that. Right. So let's just write this and let's just run it again, shall we? Oh my gosh, I can't believe that happened. I was defining r sum equals 0 for some reason at the end of that loop, because before I was just saying let's not deal with boundary conditions for the simple case where the filter is too small. And I was like, there we go, perfect. So if we look at this, we should see, wow, look at, wonderful. That's exactly what I wanted to see. So now let's do it again for the small filter, make sure it works for that. Why am I so dumb? Like, just seriously, what am I doing with my life? Like, how do I become this stupid? Like, okay, let's try it again. Include main, just make sure it works for all numbers. It should break. If it breaks, it's going to break around that point. It did not break, so now we're going to do mirage out.png. Just see what it does. Wonderful, great. Okay, so what I'm going to do next is I'm actually going to make the array be all ones, just to make sure our convolution is being generated for the entire space. So we're going to say x is going to be equal to ones of 100. And we're going to comment that out. Okay, and we're going to fix the code in just a second. So let's do include main. No method for convolution plot. That's because it has to be ones of complex float 64. Because I'm dumb. Just don't. There we go. Perfect. Not perfect yet. I'm still. There we go. Perfect. Now we're going to do include main. And let's just see what it does. So the convolution is the same for all space. Was it still the same outside? Yes. So I would reckon that this is working just fine. So we look at this. Yeah, our convolution is, it's dumb, but hey, like, it is what it is. Wonderful. Great. Okay. So we are getting values for all of space, which is what I wanted to see. Great. Good. Okay, so let's go ahead and clean this up just a little bit before committing it. We are slowly but surely getting to where we want to go. Again, there's just some comments that we have to get rid of. Well, maybe I'll leave that in there, because I don't remember what that was there for, and I still have other stuff I have to do. Hello. Okay, so we're gonna do this really quick. So let's just remove some of these comments in here. Okay. I'm also going to modify this so it's just convolution, and we're just gonna say we're just gonna have an additional variable in here, which is going to say if we want to plot it or not. So we're going to say plot equals false in here. And if we set plot equals true, it's just going to do the plot down here. Otherwise, we're just going to return the output. So if plot equals if plot, then we do that. Oh my gosh. And this way, I do not need, I think I can remove that. This way I don't need this other convolution linear. In fact, let me just change it to convolution linear because that's what I called the other one. Because the other one's a convolution FFT. And now I have to bring some lines down here. Sure. Okay, that'll do. Right. I should probably change it so the arrays are not complex float 64 anymore, but I really don't care that much. So now I can remove my other convolution linear function, which is, again, I don't know why I had two of them. I just, for some reason, wrote two of them. DD, and down there. And now when we do convolution plot, we change this to convolution linear, and we specifically say plot equals true. Here. All right, write that, go over here, run include one more time, run main just to make sure it works. Seems to work okay. So now the next thing I want to do is remove the print line r sum. Remove this line, so we're no longer setting x to be all ones. D, write that, and then we're just gonna do it one more time, include, run main. This generates a bunch of images. We can take a look at all those images, see what they look like. So we're gonna do mirage 001, and okay, the last thing we need to do before continuing is we need to flip the signal because the signal is currently, let's see, it's going up, but in fact, I think, wait a minute, is this correct? Let me think about this. So I need to think about what's going on here. So at the end of this, our convolution is slightly shifted to the left, right? But the big difference between the convolution and the correlation is where this is shifted, if it's going to be shifted to the left or shifted to the right. And what I mean by that is this purple is slightly offset to this blue, right? And so if it's a correlation, I believe it should be shifted the other way. But if it's convolution, it should be shifted this way. So the question is this actually being shifted the right way? And the answer is I think not. Because if we go back a bit, here, that's fine. Okay, so let's take a look at this. It should be, oh, I gotta think about this. Is that facing the right direction? It is going up in a triangle fashion. Couldn't something like min-max array type thing work? I guess so. I don't really, sorry, I missed that chat from like a few minutes ago. Sorry, I got hyper-focused. Let me get a little bit more water. Okay, is this correct? So it should be, it increases quickly on the way up and slower on the way down. Let me try doing this with a square wave instead, because I think if I do it with a square wave, that'll be a lot easier to understand. So let's do that. Convolution signal starts from the left, and the filter is reflected. It starts from the left? No, I think we have it the right way. I think that's the thing. Like the difference is convolution and correlation. Like it's just a difference in direction. So we have either the convolution or the correlation. I'm just not sure which one we have. The filter starts from the left, right? No, I think the filter starts from the left and it starts moving left. I think the filter starts from the right and starts moving left. I think that's the way it's supposed to go. Because if you look at the mathematical definition, oh, let's see. Convolution, Wikipedia. Right, so that's what I was going to say. Looking at the definition, right? But let me just look at the definition and see what's happening. So the definition here is going to be f of g of t is going to be, f of g of t is going to be d tau. So the idea is that at any point t, we are subtracting tau, which means you're moving left. Yeah, you're moving left. Hey, Pretz1311, how are you? Yeah, that means you're moving left, right? No, well, I mean, I guess, wait, maybe I'm thinking about this wrong, because t minus tau. Okay, okay. Maybe you're right. I need to think about it. So I know the Wikipedia visualizations go from left to right. I know they go from left to right. Like, we go down, they go that direction. But I don't trust these visualizations at all because they're super misleading. So I kind of want to... Yeah, but maybe you're right. Maybe they should go the other direction then? Maybe. Um, okay. Maybe you're right. Let's do a square wave really quick just to make sure we're getting the right convolution, and then we can figure out which direction we need to go in. Yeah, let's do it that way. Let's do a square wave, and then that'll solve all the issues. So we're gonna say x is equal to zeros of 100, and we're gonna make them complex float 64. Here, and then we're gonna say the middle, I don't know, 50 elements are square. So we're gonna say, are you gonna make a video on it? I will not be making a video on convolutions. Nor will I be making a video on genetic. Oh, I already have a video on genetic algorithms and iterative function systems, but I won't be making a video on fractal flames. I'm gonna make a video on all the things put together with the hope that this will kind of generate more clicks on YouTube and bring more people to the algorithm archive. So instead of doing like a video on every algorithm, I want to do a video on a group of algorithms put together and then turn that into a video. This helps me out in a number of different ways. The first way being, I no longer have to make a video for every algorithm, so I can make chapters way faster. And I can make videos that are in the end way cooler, so more people are likely to click on them. So that's kind of my idea. Total Chaos, I guess Total Chaos, and also Monclai, thank you guys so much for following, really appreciate it. Okay, so we're gonna do x of some subset of the array, which we're gonna say 40 to 60 is gonna be dot equals to 1.0. 0.0, there we go, plus 0 imaginary. Okay, we're gonna do include, and now we're just gonna do main and see what that looks like. Okay, now if we do Mirage, okay, so we're gonna have this guy moves over, and then we get, yeah, it goes up, and then it goes back down. So is that what we expect from the convolution? Move this over here. The convolution goes up and down. So this is the correct convolution output. We are getting the correct convolution. Now the question is the visualization correct? And it should go, let's see. So it starts off slow and goes faster. Yeah. This is also looks correct to me as well. I think it's going the right direction as well. But let me think about this again. So F star G, if the G is a triangle filter, so we're getting the same thing that they get for the convolution here. It goes up and then down in this direction, whereas a correlation will go the other way. So it, yeah, this is, yeah, so we're seeing the same thing that they're saying over there in this visualization. So let me just make this a bit bigger. So, oh, well, that didn't work. Make this a bit bigger. Over, oh, it still didn't work. Try it again. So make that a bit bigger. And so I'm looking down at this guy over here. And so it accelerates slowly at the start and then quickly at the end, right? Either you flip the filter or you make it run left to right. No, but this is correct. What you're saying right here is correct. I don't see how it's wrong. Sorry, maybe I'm being dumb here. Jasimo, thank you for following, really appreciate it. Looks good because you're basically sliding the signal instead of the filter in your visualization. No, the visualization is sliding the filter. The filter is definitely sliding the visualization. Right, because that's the red thing. So, let me get some water. And also, it makes sense intuitively. Like, this is, yeah, this is what you'd expect as well, because, oh, maybe not. Maybe you're right. Maybe it's different. Wait, let me think. Okay, no, you're right. We have to flip the filter. Yeah, you're right. The filter needs to be flipped. So, this is, yeah, okay. You're right. You're right. The filter needs to go the other direction. Because as it's coming up, Yeah, so here we have great acceleration going on to lower acceleration, but it should be lower acceleration going on to greater acceleration because it's a triangle. You guys are right. Yep. Okay, so we need to make it move the other way. But the convolution is correct. Like, we're getting the right output. It's just the visualization is wrong. That's fine. That's easy. I mean, it's not easy to fix, but we can fix it. I mean, it's probably easy to fix. I'm just dumb. Okay. So the signal plot here. Right. That also means that our convolution visualization up there is also going the wrong direction. So we're actually showing a correlation visualization instead of a convolution visualization, which is fine. That's fine. We just have to make it go the other direction. Okay. And that is literally just a matter of changing this to go the other way. Also, I'm not sure you got the right values. I think we did. What do you mean? We'll take a look at that in just a second. Wait, why didn't we get the right values? I'm pretty sure those are the right values. They look correct. But, so we're going to grab this signal 1 to I. And I believe if we flip these guys, we should have it. So let's try this. Ah, shoot. Try that again. Okay, so we're going to grab this. Paste this here. Put that there. And then remove some lines here. I think that's right. Let's go here. Let's do include main. And I think this will be the right visualization. I think. We'll see. So let's do Mirage. So this should be going right, of course. Yeah, of course. It's not moving because of where we put the zeros. So we will... Okay, I gotta think about this again. So we want to put the zeros on the other side. So this would be signal 2 there, and signal signal 1, and then zeros here, and then over here we're going to do DT. Ah, come on, DT there, and here as well, like that. I try this. So now we're going to do include main. Yep. See what this does, and now we'll take a look at the values after that. Okay, Mirage. So this should. Oh, hello. Should be go. No, that's definitely wrong. Yeah, that's wrong. Okay, I don't understand what's happening now at all, actually. Oh, no, now I do. I think I understand. Yep. 1 second. And then we also need to switch these guys. So this guy's shifted here. No, I'm still doing it wrong, I think. I need to think about this. I just screwed everything up. So if we do include and then main here. Okay, now we do include convolution.jl. Oh, no, Mirage. Then, so why is it still going that direction? Oops. Well, I tried. Okay. Also, Amras, as far as like the values being incorrect, like the final values, we're really only looking at the shape because I scale it afterwards so it fits the graph. So it's scaled by the overall area of the square in here. So that means I'm dividing it by like 50 or something in the end. So that's why these values aren't correct. I'm really just looking at the shape right now. So I can change that normalization factor at will as we need. So that's why the values might not be right. But again, I'm just looking at the shape, not the values. Okay. So how do we get the signal to go the other direction? You don't think no? Wait, how could it not be the right shape? It has to be the right shape. I mean, we can make the triangle bigger, or the square smaller if you want. 0s to n here. I'm like almost 100% sure it's the right shape, but I mean, again, I've been wrong before. 1 second, I'm just bringing it back to where it was before we made all the changes, and then I'm going to commit what we have so that at least we have something that's kind of working. Yeah, so it should go up to a point and then saturate because, you know, we're kind of, the whole thing is all constant, and then it should go back down. So like that's why I think it should go up to a level and then go down. So I think that shape is correct. But again, like I've been wrong before, like a lot of times. Okay, so I'm going to commit what we have because we know we're getting the right convolution out. It's just not going the right direction. Wait, okay, so now I'm confused. Yeah, no, the visualization is definitely not going the right direction. That triangle should be going the other way. You're right. So what I'm going to do here is I'm going to commit what we have because we know we have the convolution working now. And then we're going to get the visualization working. And that's... So we just need to move the triangle in the other direction, which we know how to do. I have that visualization available. I just had the convolution and correlation mixed up. So we're going to get that visualization up, and then we should be good to go. So let me do git status. Oh, actually, git add convolution, git commit -m for the flipped filter is the right shape. Right, that's it. We have to flip the filter. No, we either flip the filter or make the triangle go in the other direction. Either one is a solution. Adding working convolution. Now to fix visualization. It's not flipped from the main function. It's not flipped from the main function. It's not flipped. I don't know what you mean. I'm sorry. What main function are you talking about? Convolution linear? It's not flipped. You're right. Yeah, I don't. We're getting the right values, so. Yeah, we're definitely getting the right values. Okay, maybe let me call it for today, and let's come back tomorrow and let's figure this out. So I'm going to do git push upstream. I'm sorry, origin master. So it's available in the simulation layouts directory. So your filter is 1, 2, 3, 4, 5. The shape of your visualization is the unflipped filter. Correct. But that also means that the convolution is incorrect, because again, if we make the filter go the other direction, then we, like, here, let me try to explain this. So if we take a look at this guy, and let's pretend the triangle goes the other direction. Let's just move it all the way through. So let's pretend the triangle goes this direction. Then this convolution is correct for that triangle. So if the triangle were to go, towards the square at this point in time, then this visualization of this little purple line is correct for this filter. So that says to me that there's a flipping in the in the convolution itself that we have to do as well. It always feels so nice to get push. Yeah. So okay, let's call it here for today. We'll come back tomorrow and try to figure this out. So we're not fully there yet, but we've got most of it done. It's now just a matter of figuring out those last bits of the indexing. Let's see who's live and who we want to raid at the end of stream. So we have Bota's live is coding in Rust. We have Japanese printmaker doing Japanese printmaker stuff. Strange Parts. Rocket Sage, Chayonui doing math. Rocket Sage doing geology. Let's see. I think Salt and Pepper thought so too, as evidenced by their song "Get Push It." Huh. Sage, we could do Rocket Sage if you want. That seems fine. I haven't raided Rocket Sage in a while. So let's go start that raid on Rocket Sage. Raid Rocket Sage. I always forget how to spell it. And yeah, that seems good. So Rocket Sage is a geologist. She does a lot of really cool rock-related streams. And yeah, I think you guys will enjoy it. We'll see. Anyway, thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. We'll be back tomorrow to finish up the convolution stuff, basically get the get the visualization underway, and then we'll start working on the 2D stuff as well. There's a lot of stuff left to do with the convolution chapter, but I'm hoping to have it all ready to go by Friday, and then we can start working again on the Flamify package. Yeah, no, I appreciate the conversation. I think you're right. We need to figure out, what's being flipped and what's not, but we're basically there. Like, we're really close, just not fully there. Anyway, thank you guys again, and I'll see you next time. Bye, guys. Thanks, always like coming in for the competition. Yeah, thanks so much. Anyway, I'll talk to you guys later. Peace, guys.